but it's not mandatory. So snacks and water is there. Water is in the back and on the table. And if you need something else, we have a lot of waitresses running around. Just talk to them. Lunch will be around 1, and in the evening we will have an open bar and community party with a dinner. So make sure to stay around until dinner. And also during lunch, we will release a QR code on this screen here, which will lead you to a portal where you can register for your proof of attendance token, which we will be issuing only to the guys who are here. You all received the PIN, and you have to upload a photo of a PIN, which you received to receive this token. It's limited to 150. What is really important also, do not split this token, because otherwise you will not be able to make it into an NFT later this year, okay? Since a few flights got delayed, unfortunately our CTO and CEO will be arriving a little bit later, but we made sure that we can do the first presentation on a video on screen here, so you can watch it. After me, we will be welcoming Farah, our head of talent, who will talk a little bit about Radix and working at Radix. And she will be here for you guys if you are interested in any of our job offers which we have currently open. So, again, emphasis on the community party afterwards. Open bar, 3 hours, a lot of fun. So, give it up for Farah.
Thanks, guys. I didn't think I was going to get a clap, but thank you very much. So as Christoph said, I'm Farah. I'm the head of talent at Radix. But you'll see a lot of kind of RDX Works. So just to be super clear, RDX Works is the company and Radix is the network, so the Radix Engine. And everything Scripto related is on the Radix Engine. So just to be super clear, in case you were wondering who RDX Works was. So we're based in London. We've come massive way over the last 12 months since I've been with the business. We started off, I think, about 25 of us. And now, as of today, there's approximately 65 people in the business, and we're growing massively. And it's really thanks to you guys here who are working on Scripto, learning how to use it, and essentially growing the network. So really, thank you so much for everyone being here. We're growing the business massively, not just software developers, but also from an operational side as well. So like Christoph said, you'll see my business cards in those little boxes that you've seen. So if you don't want to ask me any questions now, please feel free to email me. But if you do want to have any discussions about job opportunities, we hire globally. So you don't have to be based in London. You can be literally anywhere in the world. So it's a really fun place to be. I'm going to hand back over to Christoph. And unless anyone has any questions, not just yet. I'm sure you will do later. It's still early, not enough coffee. So I'll hand back. But it was lovely to meet everyone. But please grab me if you have any questions at all.
Hello everybody, I'm Matthew Hine, the Chief Product Officer of RDX Works. RDX Works is the creator of the Radix network and the Radix protocol, and a set of tools that wrap around that like Scripto, which is why most of you are here today. Apologize for having to do this presentation this way. I was planning on being there in person and we had a last minute flight delay. Probably if you're watching this, it means I'm on the plane on the way there and I'm going to try to get there as quickly as I can. But I wanted to give you this presentation before we delve into the technical stuff because I think it provides some really important context about why we've built Radix, why we've built Scripto, and what we think it's going to be useful for. It's an opportunity that we want to share with the builder community. We want to get you excited about it, and we want to give you a little bit of a picture about what kind of applications we expect to be useful for Scripto to be useful for, and that comes down to DeFi. So I want to start by talking about why we really believe that DeFi, decentralized finance, is the future. And specifically, it's a future that we think right now is on pause. For all its potential, we feel like it's halted, and that's why we had to create Radix technology. So I want to give you a little bit of background about DeFi for those that aren't familiar with it. So to talk about decentralized finance, I need to start by talking about finance in general. So this is going to be a little bit strange, but I'm going to give you a whirlwind tour of the future of finance to bring you up, to give you some idea about why decentralized finance is the next important step. So in the beginning of finance, there was money. Money was the first financial technology. It's a little bit strange to think of it as a technology because we're so used to it, but it really was a new thing. It was an idea that you could print something or you could coin something and use this to enable financial exchange that you wouldn't be able to do through, direct barter and this sort of thing. And that technology allowed people to engage in commerce with each other in ways they couldn't before. But of course, money is very limited. If all you have is cash on hand, it means that you can only do business with the person that's standing right in front of you, or as far as you can haul money around in a wagon or in your purse. So it's very limited. And so almost immediately after the advent of money, commerce started looking for other options. There was immediately businesses thinking, there has to be a way that we can expand the reach of what we do, to provide more flexibility, to do more than just money. And so around the time of the Renaissance, you had the rise of the banks. And banks came into being to provide different things that you could never get directly with cash. This is just a selection of these things, but settlement, lending, exchange, investment, these are all different types of financial products and services that you can't just do with cash. Settlement, basically, this settlement would allow you to expand the reach of your business. You could, maybe do business with someone from cities or countries away from where you were. Lending allowed you to not just do business with cash on hand. It allowed you to expand your business with a loan that you could then pay back later, and you could accelerate the expansion of your business. Exchange then allowed you to interact between different economies, different types of currency, and that again expanded the scope of business significantly. And then of course investment created the idea of common enterprise, the fact that there could be contributions to something, and you could experience a benefit from that contribution and share in the success of another business. So really the rise of global finance coincided with the rise of global business. It's kind of funny to think about a global economy in a Renaissance context, but it very much was, but not as fast as today. But you had business that was operating across large amounts of the globe, and it was all enabled by banks. It was another really important financial technology. And that technology, the bank, was based on a new relationship, a new bargain between users and their money. The idea was that you could take your money, your cash on hand, give that to the bank, and then those banks would then have essentially the scale and the connections that would allow them to provide these services to those end users. And the way they did this was by building connections between the banks themselves. It's much easier for a limited number of banks to perform settlement over long distance, to coordinate lending, coordinate exchange, and combine their resources to perform investment. And all this bargain was based on the idea that it was safe for us to trust our money to those banks. That bargain basically is what's in place today. The modern financial system in concept is really no different than this. Now, of course, this has been digitized now, it's been modernized, the range of financial products and services has expanded greatly, but it's all still basically variations on these simple set of functions, and it's still based on this same basic bargain of a limited number of banks that interact together and allow it to be possible to build these things. It's very powerful, but here we are now in the internet age, and I think most of us agree that now the financial system, in whatever way we interact with it, you've probably noticed that something feels kind of off about it. It feels weird, and how it feels weird kind of depends on who you are. It might be that it might just be as simple as, you don't know why it is that you can put your savings in a bank, but you don't actually get, your interest rate might be zero or close to zero. And, of course, that the bank is then investing that money and they're making money on it somehow. So why is it that you don't get to share in that? You might be in a place in the world where you don't have access to a bank account, or maybe it's just the fact that the range of options of banks that you have to choose from is very limited just because of where you are or who you are. It might be that depending where you are, you don't have access to certain types of investments that you'd like to have access to. It might just be the fact that if you want to send money to somebody on the other side of the world, it feels really strange that it takes maybe days to send that money and costs you, $20 or $50 to send money around the world. That doesn't feel like a financial system in the internet age. Why isn't it better? And we have that expectation because we've become used to the idea of an open network. The internet, it was the first truly global open network, in this case for communication. It was the idea that anybody could connect to the edge of that network, and that would allow them to communicate to anyone else who's connected to the edge of that network. And what that meant is when you have this neutral piece of infrastructure where anybody can connect and the connections are unlimited, it allows for a much more competitive ecosystem of communication. It doesn't just mean that for me to be able to talk to someone on the other world, it has to be through AT&T or someone that owns infrastructure. Now it's the fact that any two people can use applications on the internet, any application on that network can compete for providing better communication services for other people on the network. And because it's more competitive, the way in which we compete is more convenient, it's more inclusive, and it's cheaper than it would have been without something like this. So of course this is immensely powerful, and it's revolutionized everything about what we do. The DeFi vision is essentially taking finance and moving it into the internet age. Now that sounds like an easy thing to say. It's like, well, yeah, of course, I can use a bank for my app now. Isn't that kind of in the internet age? But of course, it still feels like it should be better. What it feels like is there should be a form of finance that operates on the same principle as the internet itself, so that there's a neutral network that anyone can connect to, and that provides the same kind of benefits the internet gives us, except for finance. And that's possible. The first DeFi platforms like Ethereum and others are proving that you can actually do this. Blockchain technology has enabled the idea that you can have an open, neutral network that anyone can connect to. They can connect to it and own their own assets on that network. And with those assets, they can connect to a range of applications that are running on that network. And those applications can provide all the sorts of things that the financial system did: settlement, lending, exchange, investment. And it can do it in a way that should be much more competitive, convenient, inclusive, cheap. And it should also be safe, obviously. That we're not going to use a system like this if it isn't safe. So let me tell you why that's so powerful. Let's get into a little more detail, and I'm going to zoom in on this chart a bit. So if you imagine people connecting to that network, okay, so maybe I've got a wallet that I can use to connect to that network. Well, the first superpower that a DeFi network has is the idea of tokenized assets. It's the fact that what I control on that network can represent almost anything. There can be a token that's securely managed on one of these networks that represents a purely digital asset like Bitcoin. It can represent dollars that are held in a bank account someplace. It could represent ownership of an item in a game, like a sword that you've won. You have unique ownership of this object. It could be a contract, or it could be a traditional asset. It could be the deed to your house, or it could be NFTs are a really interesting new class of tokenized asset where you have unique ownership of essentially an image, or it could be other things. But avatar images and things like this have been popular in the recent couple of years. All those things are enabled by having this sort of neutral open network that has the ability of representing digital assets in tokenized form. And the cool thing is, once you've tokenized something, now they can operate through all the same mechanisms that any other tokenized asset. You don't have a system that's built for dollars or built for Bitcoin or built for a gaming asset or something like this. They can use all the same mechanisms. The same set of users can connect and use those things and own them. Okay, so the second superpower of these DeFi networks are dApps, or smart contracts. For those that aren't familiar, dApp means decentralized application. It means it's a piece of code that's running on the decentralized network, on the DeFi network. So smart contracts basically mean that I can come to the network, I can own my assets, and I can connect them into that. I can use those assets with a piece of code that's running on the same network that's managing those assets, and I can do lots of different things with this. Even with this very simple set of building blocks, we can start to represent things that we're very familiar with from the traditional financial system. So take something like a currency exchange kiosk at the airport. I've just walked by a large number of these things getting to where I am right now. traditionally you would have a bank that would be providing a large amount of capital to the currency exchange and would allow it, when I walk up and I hand them my pesos, now they can give me an exchange rate that they could take a small fee, and then they can give me an equivalent amount in US dollars, something like this. Well, on a DeFi network, you can do the same sort of thing in a very automated, direct form in code. I can have my own account, and that account can hold some tokens. So let's say I have an A token that represents some sort of asset, maybe it represents pesos or dollars. I can give that A token to a smart contract, so something like you see on the right here. It's got some logic in it, and basically it can accept those tokens, put them in a pool that it controls. It can look up a current exchange rate, and it can pull some other tokens out of another pool of the B asset and send that B asset back to my account and perform that exchange. All this can be done in a single transaction without an intermediary, without a bank involved. This can be done, instantaneously, cheaply, and competitively, because anybody can build something like this and try to build a better version on the network. Very, very powerful. Okay, so the third superpower I want to talk to is, with these decentralized applications, we can also introduce the notion of composability. Composability means that that it's not just users that can connect applications, but applications can connect to each other. What this means is you can combine the functions of many things together. You can create layers of functionality. You can have maybe there's a set of smart contracts that each perform a very specific operation very well, but those can be combined together to provide more elaborate financial services. Maybe you can even balance things. So let's say you can look up multiple smart contracts that are providing exchange, look up which one provides the best rate and use that one at that given time. Or maybe you can connect lending with exchange to do something else with this. Composability is a really important thing that has been shown on Ethereum to be immensely powerful. There are a huge number of applications that are in the background using other decentralized applications to perform functions and provide liquidity and these sorts of things that they didn't have to do themselves. They could leverage other applications that already existed on the network. And again, that's only possible if you have this combined network where everything is operating at the same level. There's free interconnections between these things. You don't have independent systems where you had to do a separate integration to some API, build a system, build an audit system to make sure that transaction was handled correctly. This is much more direct and much more efficient. The last superpower I want to mention is two-sided markets. So this is a really important concept in DeFi. What it means is that if you go back to the example of the exchange, even if I built this with a smart contract, you might assume that, well, okay, there is someone who's providing the capital. They're putting money into those A and B pools, and that allows people to come in and do those trades against those pools, and then maybe I take the fees and I go off and do something with those. But the pattern that we more often see in DeFi is that actually both sides of the market are directly provided by end users. So not only can a user come and do the exchange with a decentralized application, but also the capital that allows the exchange to be possible can be provided by individual users. Individual users can contribute A tokens and B tokens to those pools. The smart contract logic makes sure that they're handled properly. And when a trade happens, those fees flow back to those individuals that can provide the liquidity. What this means is you can massively democratize this system. It means that you don't have all of the capital being collected and provided by a small number of semi-monopolistic entities. It can be provided essentially by anyone. Once again, this means a system that's much more efficient and actually much more inclusive. It means that there are more opportunities for individuals to put their money to work in ways that are really interesting and flexible. So if you put all of these things together, this is how we get a new type of financial system. This is how you can provide all these financial services on an open network. And in the end, the result is that this world of different kinds of applications, any kind of application you can imagine, from the digitally native to something that's from the physical world that's been tokenized and onto one of these networks, all of those assets can integrate, can connect together at the same level to provide any sort of financial service you can think of. In fact, when I say finance, don't just think in terms of the things you'd get from an investment account or from a trading account or something like this. You can do those things, but it even expands to basically any form of exchange of value or use of identity. It comes into even things like the metaverse. If you have sets of virtual worlds that need to connect together, the layer that binds those worlds together is going to be ownership of assets that can carry between different universes. It's a sense of identity that can carry between these things. This sense of digital asset ownership and digital identity is really central to everything that's happening in Web3, in DeFi, in the metaverse, all these really exciting things that are going on right now. So you might assume, and you'd be absolutely right, that the opportunity for this is enormous. If you look at the TVL, so total value locked, if you take the amount of capital that's right now held by the global financial system, everything that happens in traditional finance today, it adds up to something like $400 trillion. You can define this in different ways, but it's something on this order, $400 trillion. So that is absolutely being able to rebuild that system in a more democratized way, in a more efficient way, in a more competitive way, has to be the biggest opportunity for developers that's ever existed. This opens up an enormous gold rush of developers to be able to say, I'm going to come in and I'm going to compete head to head with the banks and provide better services, better products, better ways of managing assets and identities in a way that was ever possible before, outcompete the banks, and launch whole new businesses and categories of businesses that weren't popular before. However, kind of a strange thing is going on right now. If you look at DeFi as it is today on Ethereum and some other networks are doing, but by far it's mostly dominated by Ethereum, the size of DeFi right now is $0.08 trillion. That's $80 billion. Now, 80 billion seems like a lot, but if you compare it to the blue square of global finance here, if I tried to draw the equivalent blue square in DeFi today, it isn't even a pixel on here. You can't see it. It's a tiny, tiny amount compared to the total amount of global finance. So you have to ask yourself, and certainly at RDX Works, this is the question that we asked ourselves going back something like 10 years ago was, why isn't this happening faster? Why we see this opportunity coming, and over the years we've said, why isn't this going faster than we would expect? Why aren't people seeing this opportunity? Why isn't it being taken advantage of? And the reason is that, well, in order for it to work, in order for it to take off, it has to actually provide these benefits. It has to be competitive, it has to be convenient, inclusive, cheap, and safe. And even though the potential for DeFi is there, it's not actually being delivered by the platforms of today. If you look at Ethereum, for those of you who have used Ethereum, in some ways it's really exciting. You can do all these things that weren't possible before, but it's less competitive than it should be. The number of application developers on those platforms is pretty limited. Like the number of people building DeFi applications today on Ethereum compared to the world of developers is tiny, and the majority of that has to do with the difficulty of building smart contracts on that platform. It's just the barrier to entry is extremely high to build something that's really ready for launching an application that's managing money for people. And I'm going to talk a lot more about that a little bit later. It's also not particularly convenient. If you've experienced using a wallet on Ethereum and connecting applications and using them, it's a pretty complex experience. You have to understand private keys and seed phrases and connecting to dApps and all these sorts of things. It's certainly not something that you just, if you've got a friend that wasn't into crypto and so be like, hey, where should I put my money? It's really hard to recommend that they go into DeFi because they're going to be really confused by this. And it's also not particularly inclusive, and a lot of this, again, if you've used Ethereum, you've seen the fact that oftentimes transactions, even though you'd think it should be very cheap to do these things because you're operating on the same network, it's actually really expensive in some cases. Like transactions can be $10, $50, $100 if there's a lot going on the network, because in the end, Ethereum is really, really slow. If there's any amount of transactional volume through the network, you run into situations where there's simply not enough capacity for everything that everyone wants to do. The network slows down, and essentially you have to pay more to be able to get your transaction through ahead of other people's transactions. So it becomes actually, in some ways, more expensive than the traditional financial system, which really makes the whole thing fall apart. So that reduces inclusivity, because it means that, well, unless I'm making $1 million on a trade, I'm not going to be willing to spend $100 to do it. It doesn't come all the way down to the level of the rest of us that just want to do smaller transactions. And the last issue is safety. Even though in concept we should be able to have very safe ownership of your assets on these things, in reality we see time after time millions and billions of dollars lost in hacks on the Ethereum network. And this doesn't come down to stupid developers. The developers in this ecosystem are some of the sharpest guys going on in the space, or in the world of developers. The problem is it's just incredibly difficult to build secure applications because of the tools that they have to work with today. And again, this is where we're going with Radix. So the Radix mission in the end is to address this problem. We see this opportunity. We see this once in a lifetime opportunity for developers to rebuild the system in a much better way, to provide better banking and financial services for everybody in the world. And so the reason we exist, the mission and everything we build at Radix, is to give builders everything they need to obsolete traditional finance and replace it with thousands of DeFi apps and assets. We really believe in this mission. This has been the guiding principle about everything we've done for years and years now, because we need to take finance of the last 300 years and transition it to a new system of decentralized finance that's built for the next 100 years or more. So how do we do that? There's two key pieces of technology. This gets a little bit into a sales pitch, but humor me. I want to give you a little bit of context of before we get into the details of Scripto, what's the guiding philosophy of what we're building, and give you some context of what we built. So the two major elements of our technology are these two things. One, what we built is built for builders. We have Scripto in the Radix Engine, which is this new asset-oriented way of building smart contracts, which is obviously what we're going to talk about a whole lot today. But the result is, for builders, is that we believe that we can provide the fastest path to get from an idea to a production DeFi application that can really manage millions of dollars and help create this revolution. The other half of it is that it has to be built for scale. So if we can provide this great experience for people to build applications, we need to build a platform that can keep up with all this demand and scale to handle global level finance. And so our key piece of technology here is Cerberus. This is the consensus protocol that we're in development on. This is a concept that we've published a white paper on. You can go into full details on this. It's a braided cross-shard consensus mechanism. I won't even try to explain what that means, but the result is that we have a method of providing what we believe is unlimited DApp throughput and low fees forever on this network. These two things together, we feel, are the core technology elements that you need to have to unlock this revolution, to allow decentralized finance to reach its full potential. So with that, let me give you one last thing before I end this presentation and we move on to some a little more technical stuff, is go through our roadmap. So to give you an idea of where we are in this journey. So the great thing is that everyone here in this room is in early. You're in the stage where you're at an exciting point where you have Scripto to work with, we have the ability of starting to build some of these applications, but we're on a journey to be able to get to this full vision. So I want to put this in context of where we are. The first major part of our roadmap, the first deliverable, is what we call the Olympia network. This was launched in Q2 of 2021. The point of this was that the target was essentially for early Radix supporters. It was a very simple network, and this is what's running today. It is a decentralized network, and it's the XRD token. The XRD token is what you need to operate this network. It's the utility token that allows you to pay for transactions and operate this network. It uses a simplified, unsharded version of Cerberus, so does not have the unlimited throughput that the first full service mechanism does. But it's still designed to prove the core principles of our method of consensus on a truly decentralized network that's really operated by an open community of node runners. So the network as it is today is run by people in our community that are choosing to participate. They're participating in the economic mechanisms that the network uses to ensure that they're incentivized to do the right thing on that network and make it safe. And sitting on top of that network, we have Radix Engine v1. So I'll talk a lot more about the Radix Engine, but essentially, this is the application layer of the network. This is what gives it utility. So when you're sending tokens around this network, it uses the Radix Engine, but the network as it is today doesn't have Scripto. It doesn't have programmability. It's essentially a simplified network that allows you to just send tokens from place to place. So this is the first thing we had to launch so that we could get confidence in the protocol mechanism, so we could engage our community and get them running this network and prove that our core technologies were working. The second part of the roadmap is Alexandria, and this is where we are today. The focus of this is to give Scripto developer pioneers the tools that they need to get started with a brand new buildability experience, and that's what this event here is about today, is having you participate in this form of Scripto that allows you to build smart contracts in a new way, and you're going to be able to build some stuff today. You're going to be able to go home and start writing Scripto applications. So in the Alexandria phase, and this was launched at the end of last year in December, this is going to be going through the end of this year and then beyond. I'll get that in a moment. Scripto is going to be going from its initial v0.1 form up to 0.9, so you can kind of consider this the pre-release phase of Scripto. We're kind of in the middle right now. We're at v0.1.4 is coming pretty soon. We're building up more and more functionality as we go, but we have the major components in place right now. It includes Radix Engine v2. So Radix Engine v2 is what you need to operate this much more elaborate form of state that interacts with Scripto, and again, I'm going to get into that. We've got a simulator environment and some CLI tools that you can use, and basically this allows you to experiment with Scripto. We expect that we're going to have test networks that you're going to be able to use later in kind of the second half of this year that you can use for Scripto applications. The next exciting milestone after that is going to be Babylon. So this is going to be launching at the end of quarter one of 2023. And this is going to be the point where it'll be possible to have the first deployed Scripto-based DeFi applications on the public network. So this is going to be a major update to the public network that's going to bring on-ledger Scripto v1, on-ledger Radix Engine v2 to the network. We're going to have a beta net in the fourth quarter of this year that'll have most of that functionality so you can start experimenting it, and then mainnet happens in quarter one of next year. Also at this point, we're going to have an all-new wallet. If you connect to Radix today, we have a very simple desktop wallet you can use for tokens. We're going to be launching a brand new wallet experience that's going to be built for DeFi, built for Web3, built to connect to the Babylon network that we're going to be really excited to talk about at the end of this year. And then looking at it even further than beyond that, the sort of the last major milestone in our core roadmap is called Xi'an. Xi'an is going to will launch likely in 2024, and the focus on this is pulling it all together, these parallel threads. It's the buildability experience, it's the decentralized network, and it's the full throughput of the fully sharded form of the Cerberus consensus mechanism. So this is the point where applications are not only running in the network, but they have the full scale so that thousands of these applications can be running for millions and even billions of users on the same network. And this is the point where we can truly reach the full potential for Radix and for DeFi. So basically the end of my presentation, but I've got one more slide I want to do that's just about our approach to this, and specifically our approach to working with you as developers, because obviously this is a really important part of our vision. Like, everything we're doing is about giving the developers tools they need to create a revolution, and we have a pretty strong belief about the right way of doing that. So I want to talk about flash mobs and movements. It's a very, very different, those are two different ways of creating movement in the same direction, creating action in a certain direction. The flash mob approach it's a one-off thing. It's something you can coordinate. You can call a bunch of people, you can say, hey, we're going to do this one thing at this one particular time. Maybe you pay them, maybe you just convince them it's going to be an exciting thing to do. They all show up in that place, they do their thing. Maybe there's a video that goes up on TikTok, people go their way. But it's not sustainable. It's a one-time thing that's kind of cool, but it doesn't drive its own momentum behind it. It doesn't carry on. It's something you have to organize over and over again. And if that's all we're doing as Radix, if all we're doing is we're sort of saying like, all right, here we go, we're going to organize a developer event, we're going to do a hackathon, people say, that's kind of cool, they go home and then they forget about it. This doesn't reach the vision that we're trying to achieve. What we want to do is build a movement around Radix, and the way you build a movement is a very different approach. You don't try to directly organize everything that goes on here. What you do is you have to have a better idea, or you have to have something that solves a real problem for people. If you have that core foundation, if you have something that really is meaningful and you put that in people's hands, in some ways you don't have to do anything beyond that, because they're going to say, man, this is fantastic. This is something I can really do something useful with. I can have an impact in the world. I'm going to tell my friends about this because I want them to do it too. I want to collect a group of people on me, and we can expand what we do together. So everything we do is about enabling movements. Events like this that we're doing today is about pulling people together, getting them excited, getting them educated what we're doing. But what we hope is you're going to embrace this, you're going to go off and do something with yourself, and you're going to tell your friends about it. You're going to get other developers involved. You're going to come into our community, give back to our community, show them what you can do with your code, educate more people, and expand this, because the more people that are involved, the more people build, the more valuable this network is, the more valuable DeFi becomes for more people, and the greater the financial problems that we can solve for the world together. So we hope you'll join us on this journey, because we think it's one of the most important things that we can possibly do in the world right now. So with that, I want to say welcome. After this, we're going to start digging into stuff that's a little bit more technical, get into Scripto stuff, but we're glad you're here, and we're glad you're on the journey with us. So thanks. question. I assume soon. When did? When are we getting started?
Okay, guys, we can take a seat now because Matt is here and ready to give the second part of his presentation. And Piers also just arrived. Hello. With a huge suitcase.
Sorry, is this working, the clicker? Sorry, I'll just do it the old-fashioned way. So, hello. Sorry you had to do the first part of this with a remote session. It's been an interesting last 8 hours or so. I've been trying to get here. So hopefully now I'm here in person. So if you hated the first part, if you hate the second part, now you can throw real tomatoes at me. I'm here in person for you. The first presentation was the overview about, kind of why we're all here, why Radix is here, why we invited you here, the big picture of DeFi and the technologies that Radix has been building. Now we want to start getting a little bit closer to the real reason you came here. You want to dig into Scripto code, understand what you can do with it, start experimenting with the language. Before we got down to the code, and Clement is going to take over in the second part of this session, and we're going to start actually, getting our laptops out and writing some Scripto code. Before we get to that point, I wanted to give a little bit of an introduction to Scripto. Reason being, it's a little bit different. If you're familiar with smart contracts programming today, if you've experimented with Solidity or most smart contract languages available today, Scripto is going to feel a little bit different. If you're new to smart contract programming, and that's cool too, this will be a little bit of a primer into what that means and how things get built and how they get deployed and all that kind of stuff. So I want to introduce some Scripto concepts, and then we'll get to the good stuff. So talk a little bit about the problem of smart contracts today, and this isn't to complain about things. It's kind of the reason why we decided to build Scripto in the first place. Why not just use an existing smart contract language and drop that on top of our ledger? And the reason was, in talking to a lot of different developers, we found there were some real problems they were having. The number of developers in the Ethereum ecosystem today is surprisingly limited given the size of opportunity that I talked about this morning. And it boiled down to there's sort of a technical philosophy of how the EVM, the Ethereum virtual machine, works that we found was really getting in the way of developers, getting in the way of building secure applications, and even onboarding developers into the ecosystem. So I'll go through a little bit of an overview of smart contract environments in general. Some of this may be something you're already familiar with. For people that are new to smart contracts, hopefully this gives you a little bit of an overview. Basically, a smart contract environment you can kind of think of as a shared computation environment. In fact, if you're old enough, you can kind of think of this as like the mainframe era almost. You can kind of think of it as a single computing environment, and lots of users can load lots of programs into this environment, and they all run on this single platform. So you can think of it as a platform that provides sort of computation as a service. You can pay for transactions and pay for computation. And each one of these programs, each one of these smart contracts, has its own internal state. So in response to requests, it will update its own internal variables, and you can build whatever you want with that. So quite powerful, but this alone doesn't do a whole lot. If this was the full picture, you'd be like, great, we've got a bunch of programs sitting there running things. This doesn't create DeFi. We need to have some way of those programs interacting with each other. So the other piece that the Ethereum virtual machine brought into the picture was basically message passing, the idea that you can load a bunch of smart contracts into the environment, and then they can talk to each other, and you can talk to them from the outside via transactions. This is the basic element that gives you composability. This is the idea that I can have two applications, and this one can connect to this one to get access to something. I can get an answer back. We can coordinate lots of activity. And in fact, this is how tokens are even implemented on Ethereum. Each token that you issue is its own independent smart contract. It has its own independent logic for how you keep track of where all those tokens are, and I'll go into that a little bit. So this is the state of basically every smart contract platform today. It's done in slightly different ways. Maybe the language that sits on top of it is different, but the concept is the same. The basic paradigm of a smart contract platform has been basically unchanged since Ethereum came up with it. And this was a huge breakthrough that enabled kind of, the generation 1 of DeFi. However, there's a problem with this. So let's go back to, I think in the first presentation, I gave you this quickie little diagram of like, imagine you were doing a currency exchange, but doing it in a smart contract platform. So imagine, so that some of you may be familiar with Uniswap. Uniswap is an incredibly popular application on the Ethereum platform today. It's basically allows a user to swap between two different tokens on the platform. And so you can think of it in this very simple conceptual way. The idea of, I want to do a trade, I send some tokens to the smart contract. The smart contract does a little bit of calculation on what the exchange rate is from token A to token B, and then it pulls some tokens out of its own pool and hands them back to the user. Very straightforward. The problem is that this isn't actually how it gets built. If you want to express this in the structure of the EVM, where you have these independent smart contracts that are sending messages to each other, a lot of the pieces you would need to build it this way don't exist. You have to implement them from scratch in independent smart contracts. So in reality, the swapping function of Uniswap ends up looking something a little bit more like this. It's kind of messy. This works. This is how it works today. But you have independent ERC20 contracts. For those that aren't familiar with it, it's sort of a standard for implementing a token. But each one of those smart contracts has its own set of interfaces. You can say like, hey, I want to do a transfer. I want to look up the balance of something. And so your top level smart contract needs to do all of these message calls essentially to these other smart contracts in order to say, well, I want to do a transfer of this and to move it in the pool. Now I want to get some other tokens to hand back to the user. This all happens through this coordinated message passing between these smart contracts. And because each one of these smart contracts is independent, you can't necessarily rely on the behavior. The one developer didn't deploy all these smart contracts. Uniswap had to rely on the fact that there are lots of different tokens out there that people are going to want to swap between, and so it needs to expect a certain standard interface, a certain set of methods on those token smart contracts, but nonetheless, it can't guarantee the behavior behind those methods. So internal to its own logic, it has to do a bunch of additional checking. It says, when I do a transfer or when I'm going to look up a balance, I need to make sure that's actually correct, to make sure that this isn't some malevolent smart contract that's pretending to be a token contract, but actually does something funny when you try to interact with it. So there's a lot of this extra logic that goes into making sure that nothing goes wrong, to make sure that you get the behavior that you actually want out of it. And so this is the thing that we heard a lot of smart contract developers complaining about, the fact that, one of the quotes that we love talking about, someone says, yeah, it feels like I spend about 10% of my time actually writing the logic of the thing I care about, and about 90% writing all this kind of security code to make sure that there isn't some edge case that I forgot about that's going to lead to a bunch of money getting lost. So this was a problem that we felt like we needed to solve, and it felt like this is not something that could simply be solved by saying, well, we just need to, Go is more accessible than JavaScript or something like this. It's deep to the platform, and so when we started coming up with the smart contract approach for Radix, we started from the platform and worked up, rather from the smart contract layer going down. And so we have a very different approach. So Radix Engine v1 is the first version of this different approach. This is what's running on the Radix network today. It's very simple, I think, as I mentioned in the other presentation. Right now, if you connect to the Radix network, basically you can create a token, you can send those tokens around. That's about the extent of the functionality. But it's expressed in a very different way. There are no smart contracts running on the network, but the difference is that we have tokens as an actual native first-class feature of the platform itself. It's a very different approach. The platform and the protocol understands tokens. It doesn't push it up to the application layer. And we implement those tokens through, you can see the little FSM notation there, finite state machine, for those that are familiar with that term. Basically what that means is that we have kind of a specialized piece of logic inside the platform that ensures that tokens can only do certain things. Like the notion of a token is, one person can hold it at a time. There are certain rules about how you move that from place to place. That's all built into the platform. And this is working today, and it works very well. However, this certainly isn't the end of the story. If you don't have something more than this, you can't build smart contracts, you can't build DeFi. What we're missing is the ability of creating logic around all this stuff and customizing it and building really powerful things. So the question we asked ourselves is, how do we combine what the Ethereum virtual machine does well, this idea of powerful flexibility, of a shared computing environment, and combine that with this notion of assets as a first-class feature of the platform that we think is really necessary if these platforms, if basically their reason for existing is managing assets. This needs to be part of the design of the platform. And so the solution was Radix Engine v2. This is what we have in a simulator environment that you're going to be using today, and this is what's going to be moving onto our public network with our Babylon release. BetaNet's going to be end of this year, and mainnet in the first quarter of next year. And what it does is it keeps that finite state machine that manages assets on the platform, but it makes it more flexible than it is in Radix Engine v1. Now, rather than just sort of saying, okay, we have tokens, we have a more generic thing that we call resources. And we're going to talk a lot about resources and how they work and how you customize them. But basically, resources are the generic form of anything that you want to have ownership of on the platform. You can use it to model tokens and NFTs and all kinds of cool stuff. But all of that, the basic functionality of ensuring this intuitive physical behavior of passing assets around is still provided by the platform. But then on top of that, we provide the shared computation environment. We have the ability of deploying smart contracts to the platform. Those smart contracts can interact directly with those resources. And of course, they can also send messages between each other to coordinate activity. There was a lot of, it looks very easy on the slide. It's like, all right, just drop that in there and you're done. This required re-architecting everything we did about the platform. I mean, the virtual machine that we built is really nothing like the way the EVM works. It was a ground-up rethink because everything needed to be wrapped around this concept of resources. That was the primary thing. And you'll get a feel for what that really means once we get into the Scripto code. It's quite powerful. So let's talk about the asset-oriented toolbox. So taking this approach of wrapping all of our logic around resources, what it does in the end is creates what we think of as a new paradigm. I hate to overuse that word, but it's a new way of thinking about smart contracts that we think of as asset-oriented programming. It's the idea that when you're writing code, you should be primarily thinking in terms of what are the assets that I'm going to be interacting with? How do I want those assets to behave? How do I manage them? What's the logic I want wrapped around those assets, rather than thinking about it from the other point of view of building logic that sort of creates asset-like behavior. So we've got this set of tools that we provide that are implemented in Radix Engine, but pushed up to Scripto in syntax that you can make use of when you're programming. So again, starting with Radix Engine v2, we have some top-level entities that Radix Engine provides. So if you start with the global state being the status of everything that is recorded in that shared computation environment, the top-level entities are these three different things. Now, if I drew the same diagram for Ethereum, there would just be one thing on there. It would just be smart contracts. That's the only entity that sits at the top level. In our case, we have components, resource managers, and packages. Components and packages kind of go together. Together, those form the logic layer, and I'm going to get to that in the second part. What I want to start talking about is resource managers, because this is the thing that's really pretty unique about what we're doing. So, some entities that are related to this. So the resource manager itself has some things associated with it. First of all, it has an address, and that address refers to, you can think of it kind of as sort of the official, unique identifier for a given token. So if I ask the platform, say, hey, I want Matt's cool token, it's going to say, cool, Matt's token has its own resource manager. It hands me an address back for that. Also, at the same time, I can specify a set of flags, and I can specify some metadata that apply to Matt's cool token, so the entire thing. It also contains the functions that I'm going to need to sort of generally do top-level things with that token. So if I want to mint more of my token, or if I want to burn some of those tokens, or if I want to look up parameters about generally that set of tokens, all those are provided by the resource manager. You might be thinking, well, this sounds kind of like an ERC20 contract. It's like, okay, it's this thing that sits on the ledger and you can interact with it to do token stuff. The critical difference is that it does not contain a list of balances or owner addresses. It isn't keeping the ownership of the resources is completely separated from the resource manager. It knows nothing about them. That's all provided in the resources themselves. So, excuse me. So you can kind of think of the resource manager as more of a control panel. It's something that you go to when you want to say, okay, I need to create more of these tokens that didn't exist, or I need to do some general lookups. You can go to the control panel, you can do some stuff, but once the tokens are kicked out and they're floating around the network, they live on their own. And so those resources are the things that would actually represent tokens, NFTs, badges. I put an asterisk about that one because that's kind of a new concept we've come up with that is really cool for authorization mechanisms. And any other asset type that you can think of can all be modeled as a resource. There are two major types of resources, fungible and non-fungible. Those of you that are familiar with NFTs will be familiar with this, but this is kind of a more generic form of it. It isn't a specific type of NFT. We're saying it's just the idea of fungibility. You can have a token where every one of those tokens is exactly like all the others. So if you're trying to model euros or something like that, you'd use a fungible token. But if you wanted to have a deck of cards where you have unique cards, but they're all part of a single deck, you'd issue that as a supply of non-fungible resources. And all of this physical behavior that those resources have is customized by resource manager flags. I'm going to talk quite a bit about what I mean by that physical behavior, but at a basic level, you can imagine it's this idea of if I have something, I want to be able to transfer it between people, and I want to feel that very intuitive. I don't want to have to rely on customized methods to implement that behavior. We have another couple of interesting entities in here that are new, that don't exist on other platforms. One of them is the vault. So a vault is a persistent container of a single resource address. So if I have Matt's token and I want to hold Matt's token in my account, I need to create a vault which is compatible with Matt's token. If you try to put any other type of token into a vault, the platform will simply reject it. So you would expect that you're generally going to have many different vaults for these tokens, but you know that if you go to a given vault, you know what's going to be coming out of it, and it's guaranteed by the platform. Those are the persistent containers. All resources on the platform are always in the state of the ledger are always held within vaults. You can't have a resource that's floating somewhere that's not in a vault someplace. And vaults, in turn, are always held within a component. You can't have a standalone vault that's sitting out there. I say component. I put an asterisk on there to remind me that you haven't heard that term before. A component is basically our form of a smart contract. I'll talk about it. But for now, just think of it as a smart contract that's holding that vault. But the last new piece of this picture is the bucket. Buckets operate kind of like vaults, but instead of being a persistent container, they're a transient container. So they also hold a single resource type, but basically buckets are used to just carry resources from one place to another. So if I have a vault and I want to transfer tokens to a different vault, I would need to pull them out of that vault, stick them in my bucket, take that bucket somewhere else, and then dump that bucket into the vault. So you have these kind of physical metaphors that you can use. So let me give you an example. Let's say I want to create my coin as a resource. It's, my coin is something I want to create. I want to do something on the platform. How does that work? What's the life cycle of this? It looks kind of like this. What I would do is I would request to the platform, and I can do this in Scripto code or I can do it in a transaction. I would request to the platform, say, hey, I wish to create a new resource manager for my coin. And I would specify some things. I would say, okay, I want this to be a fungible token. I want the name of this to be my very own first token. I want the symbol to be my coin. And I want to specify that it is a fixed supply of 1 million. There'll never be more or less than 1 million my coin in existence. And this is just an example. There's a bunch of other things that I'll get to. The platform comes back and says, okay, great, here's your resource manager, here's your address. And it also, because I specified a fixed supply of 1 million, it says, well, I've got to create those 1 million, they've got to go someplace, so here you go. I'm going to give you a bucket back of 1 million my coin. Do whatever you want with it at this point. So then in my code, or in my transaction, I would then need to take that bucket and put it into a vault someplace. So by the end of that operation, I would need to find a vault that's in a component, and I would need to put that bucket into the vault, and then at the end of that transaction, there would be 1 million my coins sitting in that vault. So, and then after that, the life cycle kind of gets predictable. So it would look something like this. And basically, this is kind of a simplified form of that finite state machine that we have wrapped around resources. All resources behave this basic set of behavior where they start life as a mint operation. So when you create the resource manager, or maybe when you come back later and say to the resource manager, hey, this is a mintable token, I want some more of those, it's going to mint some tokens, it'll put them into a bucket, then that bucket needs to go into a vault somewhere, and then it's going to spend most of its life going back and forth. It goes into a bucket, goes someplace else, goes into a different vault, and so forth, according to various rules. And then maybe at some point, if it's possible to do so, maybe at some point I want to burn some of those tokens and reduce the supply. So all resources in the platform spend their lifetime moving through that cycle in various ways. And to customize that, we provide these flags that allow you to change how that physical behavior works. Because if you imagine how we expect an asset to work in the real world, and be very expansive when you think about an asset. I mean, this could be a dollar bill, this could be a trading card, this could be a contract, it could be a virtual item from a game, it could be anything at all. What we expect from the real world is that there are certain rules about how I do this. Even though physical objects themselves behave certain rules, I can't sort of miraculously create a bottle that didn't exist before. There's only one bottle. I can't destroy it unless there's some way in which it's being provided to destroy it. Nonetheless, there are rules. You know, a water bottle, I can just give this to anybody, but if I've got if I have a contract that represents a security, well, there are legal things that say, well, this can only be transferred to someone according to certain rules that are provided by regulatory bodies, as an example. So what we need to do is when I create the resource, I need to be able to customize how you can move between these states. But what we want to do is do this without having to resort to pushing it all to smart contract logic, because then we get into all the problems that caused issues on Ethereum. So what we found is that this fairly short set of flags becomes really, really powerful. You'd be surprised how much you can model this, and we'll get to some of the use cases of this, but we've been eager as we've been building Scripto to understand use cases that people have. We've been looking at things that have been built on Ethereum, we've been responding to our community with all their great ideas, and we've been putting it into this model and trying to find, is there something that breaks this? Is there something that, like, someone wants to build something, and we go, yeah, you know what, there's just not a flag that works for that, and yeah, sorry, you can't do that on Radix. What we found is that it all fits into this model, which to me means it's a really nice way of thinking about resources that's going to be very extensible. So the flags that we have right now are mintable, which basically means this resource, you can create more of it as possible. Burnable, which means it is possible to destroy some of them. Freely burnable means anybody can burn it. As long as I have it in a bucket, I am allowed to burn it. It's a fragile resource. Restricted transfer means there's some kind of rule that says you can't just pull that out of a vault and send it someplace else unless you are authorized in some way. And authorization is something, we've got kind of a general concept of authorization that we can apply in here, but there's some sort of rule that restricts the transfer of that. Recallable means that someone that has the correct authorization can reach into a vault and pull it out of there even though they aren't the owner of that vault. So you would use this for things that, you know, there are a lot of things that you wouldn't want to use this for, but there's certain types of assets that the original issuer needs to be able to pull these things back from wherever they are. Transient's a really interesting one. It's very powerful but very difficult to describe. Basically, transient means that it's a resource that you can't put in a vault. All you can do is you can mint it into a bucket, you can pass it around, and then you can burn it again. Seems like, why would you want to do that? There's some really, really cool use cases for it, but just mention that it exists, and we can get to that when we get a little more advanced. And then to go with these basic flags of behavior, we have a set of flags that specify, are you allowed to change those flags? So, for example, I might have originally not set a resource to be mintable, but I might have left the possibility of making it mintable in the future. And there's a different authorization I would have to provide to do that. So if you, for example, if you wanted to truly guarantee that a resource was never going to be created, you would have to both not specify mintable, and you would have to specify that you're not allowed to change the mintable flag. With that, now anybody that's looking at that resource can say, okay, with absolute confidence I know that this will never increase in supply. And in fact, the wallet we're building is going to have features like this. The wallet will actually show users when they hold a resource, it can describe what the physical behavior of this resource is, which is something that's not possible when you're building with smart contracts. And the last point is there's authorization that's wrapped around all these things. And again, I keep mentioning this, and this is related to that badge concept. At a high level, we have this notion of badges which are resources themselves, represent authority to do things. So the idea here is, let's say you only want to allow certain parties to be able to mint a token. Well, what you do is you create badges for those parties, and you have to present that badge in order to provide authorization to do that thing. So it's all wrapped around resources. We'll get into using that a little bit later. And then one last point here. This is going to change a little bit in Scripto v 0.4. So we're on 0.3 right now. Just to let you know that the flags, the basic concept of this we're very committed to, and this is going to run forward. Kind of the way we express this in a set of flags is actually going to change a little bit in the next version. It's going to become actually quite a bit more flexible. So rather than having individual flags, you'll be able to specify kind of rules like, well, this is mintable if 3 of 5 of these parties agree to do it. And there's some more elaborate stuff you'll be able to do. But for now, we've got a simplified form that you're going to be able to play with today. Okay, so we've done resource managers. Now let's talk about components and packages. And these go very closely together. So components, as I mentioned, are basically our form of smart contract, but a little bit different. So a component kind of looks like this in terms of the pieces that make it up. You have this general wrapper, which is the entity that sits on the ledger and has an address and so forth associated with it. It has a set of methods, so this is similar to smart contracts where there's methods you can specify on the thing that you can use to interact with it. Also similar to a smart contract is that you can have data associated. You can have state, you can have a set of variables and so forth that you can update according to whatever logic you want. But there are a couple of things that are different here. One of them is the fact that, as I mentioned, components can contain vaults. And this really is basically, you can think of it kind of as a new data type, but it goes beyond just a data type. It's something that the component holds. It's part of the structure of the logic, but it has to adhere to these physical rules of resources, like I mentioned. And we have special syntax in Scripto that allows you to interact with vaults in that sort of physical way. The sort of functions you're going to see is going to be like take and put, rather than changing the value of a variable. The other thing you might mention is nowhere on my little picture here do I show the code. Like, where's the logic of this thing? Isn't that defining the component? The answer is it's actually not. And the reason it isn't is it gets to the blueprint part of it. You can see that I've called this component A, but what does that blueprint A mean? Well, basically, component A is actually just an instantiation of a general template. And that template is called a blueprint. The blueprint is where the Scripto code resides. So when I am deploying a piece of Scripto code to the ledger, what I'm actually going to be deploying is a blueprint. In fact, what I'm really going to be deploying is a package that can contain multiple blueprints. Packages are just kind of a way of wrapping a bunch of blueprints together that are related to each other in some way. So each blueprint can serve as a pattern for many components. So it would define the Scripto code that would define the methods you can interact with. It would specify these are the types of vaults that it's going to have. These are the data types that it's going to expect to keep track of. And in the end, to create the component, you're going to have to build some kind of instantiator pure function. So I say that I called that new, but it could be anything. It could be create my cool thing, whatever it is. And that instantiation function is going to be responsible for performing the instantiation and creating this component. So from blueprint A, I could create 50 different components, but if I'm clever, I build my instantiator function with some customization. I build it so I say, well, here's a general description of this functionality, but depending what you're doing, you can specify some parameters to that new function, and you can get something that maybe works with a different set of tokens than I would have expected, or has certain other changes that you want to make to its functionality. Okay. One of the reasons this is really cool is because it enables this concept of a blueprint catalog. So the blueprint catalog, and if you read our DeFi white paper on our webpage, we talk quite a bit about this, and this gets into royalties and other things we're doing. But the notion is everything you deploy to the Radix network happens through this method of deploying a package that contains a bunch of blueprints. And what that means is that the ledger is going to be full of these sets of canned pieces of functionality that other people can make use of. It's kind of taking open source and going even further with it, rather than having a GitHub repo and people can kind of share code and say, oh, that's a cool piece of code, I'm going to copy this and do something with it. You actually have a functional template that lives on the ledger, and you're going to be able to see that, hey, blueprint A has already been instantiated 100 different times, and I can look at those components and I can say, oh yeah, those components, they haven't been hacked, they're doing really well, they're doing, I can have confidence that this is working really well. Okay, I can use that as part of my application as well. I'm going to instantiate from this blueprint, and then maybe I'll build some new functionality that'll interact with that. So it becomes this really powerful mechanism for composability, for modularity, for reuse of code, and also gets into royalties, where if you build a really cool blueprint, the platform will pay you for it. Instantiation of components can also be, it doesn't have to be one-to-one either, and I just want to get this concept in your heads because it's easy to assume this. So if I build blueprint B here, and I had my new function for this. Blueprint B could also instantiate a component from that blueprint, but could instantiate other stuff at the same time. So I can write arbitrary scripto logic in there. So you could say, maybe I have like a top-level blueprint, but it deploys this whole set of functionality that all works together that creates my decentralized application. So I can deploy something from Blueprint B. Maybe there's someone's already built an Oracle component. Okay, I'm going to instantiate one of those as well. I'm going to customize that. And then I need to kick out 2 resources that I need to use as part of this. All right. So there's quite a bit of flexibility in what those things can do. So that's components and blueprints. Now, you might be asking yourself, like, all right, this sounds cool, but you know, where are the accounts? Like, how do you actually interact with this stuff? Like, what is an account in this structure, and how do transactions work? Because transactions are in the end the thing that actually brings all this to life. If you have just a bunch of static code, it doesn't do anything. So how is it that users and other code interact with this? And the answer is it's quite a bit different than what other platforms are doing. So accounts, by comparison, on Ethereum, an account kind of works like this. It's basically it's an account address that's generated from a public-private key pair. So you can, in your wallet, you can generate that key pair. The public key then basically defines an address, and then you can use that address to interact with smart contracts. And so people have implemented this notion of holding tokens by saying, well, okay, we can have a bunch of smart contracts that each represent a token, and inside each one of those smart contracts, I'm going to keep track of a list of addresses and a list of balances associated with that. And so if I'm Alice and I've got an address, I can go to that smart contract, I can say, hey, what's the balance associated with this address? And it comes back and says 50. You've got 50 USDC tokens. And then I can do that for all these different smart contracts. And then my wallet can present me with this collected view that says, okay, you've got these 3 different tokens in some amounts. It's a little bit weird. This is actually surprising to some people if they're not Ethereum developers. They kind of go, oh, is that how tokens work? Weird. Because it feels very abstract. It feels like, you know, why is it that it kind of feels like having accounts at a bunch of different banks. It's like you don't hold your money. You just have to go to your bank and say, like, hey, what's my balance? What's my balance? What's my balance? Which is kind of backward from like how we assume that these networks work. We kind of think that, you know, the idea of DeFi and crypto networks is the fact that, like, I hold my own tokens. I've got self-sovereign control of my stuff. Where in fact, you kind of do. You own your address. No one can take that away from you. But in the end, you're relying on these different smart contracts to register your ownership of different types of tokens. So it's a little strange. So with this asset-oriented approach we took, we went back and structured this very differently, and we built it around how people actually expect it to work. On Radix, an account looks like this. An account is a component. There's a master account blueprint, and anyone can instantiate a component from that blueprint, and that account is set up to hold a set of vaults, so it can hold any number of vaults, so it can hold any sort of resource that you can imagine. And it has a set of methods that come with it. Now, this is a very, very simplified format. The real account is something that we're still working on, and so when we get to network deployment, this is going to be a pretty elaborate blueprint that we're going to provide. But the most core functions and the stuff you're going to play with today, the most important functions are the ability to withdraw and deposit. So you need the ability I need to be able to go to this component, prove who I am. I need to be able to sign a transaction, say, hey, I have this key pair, I can produce this signature, and with that signature, that gives me the right to withdraw some tokens from a vault, and then I can go someplace else and hand them to a different smart contract or do something else with it. And in this model, your ownership of those tokens is real. This isn't sort of looking up something with, your account isn't talking to the resource manager to do this. The ledger itself says, I can see there's a component here, and I am registering actual ownership of these resources to these vaults within this component. It's very, very direct, and it's very, very platform guaranteed. So let's look at how this actually works in a transaction. So let's say that I'm Alice, I've got some stuff in my account, and I want to do something really simple. All I want to do is I just want to send some tokens to Bob. It looks kind of like this. The design of our transactions is also different. Again, if you're familiar with Ethereum, you've probably seen signed transactions. Basically, it's just you're signing a hash of a call to a smart contract. That's all it is. It's just a message that you're sending to a smart contract, and then that smart contract does hopefully whatever you expect it to do. So that goes back to that drawing, that diagram I showed of Uniswap, where you had this one call, but then there's all this abstracted stuff behind it. That's what's going on there. In our case, our transactions is something we call the transaction manifest. It's a description of asset flows that you want to have happen on the network. It's very, very direct once again. You can also think of it as an intent-based transaction. You're telling the network, this is what I desire to happen. And it's all described in terms of resources. So if I want to do a send, the way this works is my transaction manifest contains basically 2 lines, a little bit simplified. But the first thing is I call the Alice component. I'll call its withdraw method. And again, I've had to provide some authorization to this via signatures. That's a detail. But basically, I tell Alice, yep, I am Alice. I wish to withdraw 5 of this type of token. And then the count component goes, great, you can do that. You have the right authorization. I'm going to hand you a bucket of 5 tokens. Do whatever you want with them. Then in the second line of my transaction, I say, okay, I'm going to take that bucket of 5 tokens, and I'm going to hand that to the deposit method of Bob's component. And the deposit method basically is willing to be like, well, if you want to give me some money, go right ahead. No authorization required. You can hand it a bucket, and it'll happily just deposit it into the account. So at the surface, it feels a little bit indirect. It's like, well, on Ethereum, I can just call a transfer function on the Scrypto Smart contract and say, I wish to transfer to Bob, and it does that thing. But in the end, this is actually a much more intuitive way. It's the expectation of how we would expect to do it in the real world. It's basically like, Alice, it's basically like pulling the wallet out of my pocket and saying, all right, I own my wallet. I'm going to pull $5 out of my wallet, and I'm going to walk over to Bob and say, here you go, Bob. And he goes, great, I'm going to put that in my wallet, put my wallet away. It describes that asset flow that how we expect things to work from the real world. And what that means is I can describe very intuitive things about very complex transactions that I want. The transaction manifest can specify essentially any number of these sorts of asset interactions you want. And this gets into composability, which is really powerful. It means that I don't have to just go to a single smart contract and say, you're going to do this thing for me, and you've got some custom logic that maybe goes off to the network, does a bunch of stuff. I can say, okay, the first thing I want to do is I want to take out a flash loan from this component. I get a bucket back from this, and then I want to turn around and I want to put it into this exchange thing, and then I'm going to get a different token back, and I'm going to do this other thing, and in the end, I'm going to pay that loan back, and I'm going to put the rest in my pocket. I can describe that line by line in the transaction manifest just in terms of where do I want the assets moving between these things. I didn't have to deploy a special smart contract to do all those things. Very, very intuitive. And in fact, the wallet that we're building will be able to interpret this and give the user very clear expectations about this is what's going to happen. You're not just signing a hash. You're going to be signing a description of something that the user actually wants to happen with the stuff that they own. So it's very cool. Okay, we're almost to the code, I promise. Last few things I want to get to before I turn things over to Clement and we start really getting our laptops out. So to give a little bit of context about what you're going to be working with today, I want to talk about the full dApp stack. And again, if you're a Ethereum developer, this is going to feel kind of familiar. If you're new to smart contracts, it might be a little bit new. Basically, the expected dApp stack, if I say I'm deploying a dApp that's going to do something on the Radix network, what does that mean? So a dApp that you're building basically has 2 major parts. There's the component part of it. There's the stuff that you've deployed to the ledger, and it's a set of components and resources and all those sorts of things that you want as part of your application, and that's what I've been talking about. The other part is you need some kind of user interface to it. So ultimately, you're going to have some sort of UI web app that you've built. It's very much kind of the Web3 model of this. So we've got something running browser side. That application can talk to the network and it can query state. So you can kind of think of it as a back-end, front-end relationship. Your components are your back-end and your web UI is your front-end. The front-end can talk to the network and say, okay, hey, I need to get current balances of these 3 things and I need to look up who has permissions. Okay, I'm going to put that all in a user interface for the user. And then in the end, the user is going to come to that interface. They're going to connect their wallet. And they're going to say, let's say I want to do that swap transaction. I want to go between 2 different coins. So the UI here would say something, okay, right now, if 5A token can be swapped for 8B token, I click go. And in the end, your web app is going to take that request and build a transaction manifest like I described. It's going to describe the desired asset flows and the contract interactions. And it's going to hand that transaction to the wallet. The user using the wallet will then be presented with something that they go, oh, okay, I can see, yep, that was what I expected that web UI to be doing. A tokens are going to come out of my account, B tokens are going to go back into my account. Great, I'm going to sign that. And then in the end, the wallet submits that transaction to the network. The network processes it, makes sure that nothing incorrect has happened, and then your UI can be notified. It goes, oh, okay, great, I can see that goes through. I can update things and do stuff. So that's the basic flow. However, for right now, for today when we're going to be interacting, we've got a simplified form of this. So in Scripto v0.3, we basically pull the front end part of it out of the equation. Right now, the tools we have are focused particularly on that back end part, and that's what we're going to be building today. You're going to be using a set of Scripto command line tools that are going to allow you to read, state, and push transaction to the simulator environment. The simulator environment has none of our consensus stuff. It's not like a simulated network. It's basically you're going to have a file system-based ledger that's sitting on your computer. It's going to be running a canned version of Radix Engine v2, and you'll be able to interact with it with command line tools as if it was a wallet or as if it was a transaction or an app. We intend to change this as soon as possible, which I'll actually get to, but basically this is what you're going to be using today. The toolchain, so those that want to dig a little bit deeper into it, like what does Scripto mean, what does deployment and all that kind of stuff look like. If you start with your Scripto code, deploying that means you're going to be combining that with a Scripto standard library. And again, the command line tools that we have do this automatically. So when you get the Scripto project, when you initiate a compilation, what it's going to do is going to be combining your code with a set of standard Scripto libraries. It's going to be running all of that through the Rust compiler, which we've added a Scripto extension onto. That Scripto extension implements all of this asset-oriented stuff that we've created for the Radix engine. So the notion of vaults and buckets and all the different functions that interact with it, all the rules of creating accounts and blueprints and all this new stuff is all built into this Scripto extension that we built into it. In the end, that's all going to be compiled down to WASM, and then that WASM is published to the network and where it can be executed. So obviously, it's not immediately executed. The first thing it does is it goes up a blueprint, but then once the blueprint is there, now you can instantiate it to a component, and now you can interact with that component. When you do a component interaction, the Radix engine is responsible for running that WASM, so it's going to be taking the input, producing an output, ensuring that all the rules are followed. So this is where it guarantees how resources can move, make sure that everything's in the right vault. And then in the end, if you have a valid transaction, it gets recorded to this file system-based ledger, which represents, ultimately on the Radix network, would be consensus. It would be the network state that is immutable and maintained by the network. That's the basic toolchain. I think this is my last slide. So looking a little bit ahead on the roadmap, so as of v0.3 today, we've got some notable updates. So as you're going things, I want to have you a little bit of context about like what, if you have questions about like, well, what about this? This seems missing. There are a few things that are definitely coming. Coming soon is going to be an improved method of auth definition for blueprints and resources. So the thing you're going to be working today, again, is a very stripped down form where you can specify simple authorization to being able to do things. We've got basically in the next release, we're going to have this much more flexible auth model, which we're really excited about. Also, we want to get to, as quickly as possible, a very simple method of connecting a web front end to components. So we don't have that today, but we're certainly aware that development gets a lot more exciting if you can put a user interface in front of it. And we have a whole community of user interface designers that really would like to get into building stuff for Radix. So we're working on at least a way of, short of having a real wallet, basically a way of creating a simple API between a web front end and the simulator environment. And again, this is coming very soon. Then other things that are going to be implemented before we get to Scripto v1.0. We're expecting v1.0 to be at our Babylon betanet. It may be 0.9 at that point, but basically the major functionality is going to be in by betanet in December of this year. Things that will include calculation and payment of network fees. So obviously, if you're going to have something on a consensus network, ultimately there has to be a mechanism of paying for transactions on that network. Again, part of our consensus approach is that network fees should be quite low, but nonetheless, if you have a very complex transaction versus a very simple one, the user has to pay more for that, so we need to meter those transactions and charge fees. We have the design for that, but this is going to be actually implemented in code a little bit later, and you'll see how that works. Also, the royalty system, which is a really cool thing. I would love to talk about just the royalty system for an hour, but we have limited time here. But you can read our DeFi white paper, and it goes into the concept of this. It's a really neat idea where basically, if you've built cool code and other people are using that code on the network, you can specify that you need to get incrementally per transaction paid for that code. We think this provides a really nice way of getting sort of incremental revenue and recognition for good work, even anything from adapt to a very small piece of core functionality that people use over and over again. So again, we have the concept for this, but in terms of experiencing that in Scripto, this is going to come a little bit later. Test networks, obviously, we've got this in works, so kind of in the back half of this year, we're going to start having some test networks ahead of BetaNet that you'll be able to interact with. And then we're also going to have a significant update to our Gateway API. So the Gateway API is the API to the Radix network itself. If you want to have queries about current ledger state, you can do that currently on the Radix network today. We have a Gateway API, but obviously this is going to have to be quite a bit expanded with Radix Engine v2 to include being able to look up. We're going to have events that can come out of things you can look up. You're going to have all sorts of internal components that you're going to have to look up. So there's going to be a big update to that. Oops. What happened? Okay. Yeah, and then lastly, the DeFi wallet. So I'm not going to talk about that a whole lot, but we are currently in development of a wallet that would be part of this ecosystem, very much in kind of the Web3 model. Those of you familiar with MetaMask, I would say that MetaMask set a really interesting pattern for this, the idea that you can have a wallet which can directly connect to a web app. That's a really powerful model, except we feel that we can go quite a bit further with that concept. So we've got some really cool stuff that we'll be talking about towards the end of this year, but you can expect that there will be a very powerful wallet that we're going to be providing. It's going to be available for mobile, it'll be available as a browser extension, and this is something that users will be able to use to connect to the applications that you build. And that's the end. So without further delay, I'm going to turn it over to Clement, and we're going to start writing some code.
So we are now going to go into actual Scripto code. And throughout the day, I will go through 5 examples, and I will explain each of them. Each example are starting from being easy to being a little bit harder. So first, we will do a really simple blueprint, which is just a Hello World blueprint, where you will learn to create tokens and how to move them around and store them in Vault and move buckets. Next, we will build a gumball machine, which will be a blueprint that will accept a payment from a user in XRD and then return a gumball back. Next, we will build on top of this previous example by adding authentication so that the admin of the blueprint is able to withdraw the collected XRD. And then we will get into how to create non-fungible resources on Scripto by building a image collection representing gumballs with different attributes. And next, we will go over a more concrete example of how to do a decentralized exchange with Scripto. Before starting, you need to get your environment set up. So you need an IDE that supports Rust syntax. We recommend VS Code with the Rust extension. Next, you need to install the Scripto Toolchain to be able to build your code and deploy it to the local simulator. And finally, you need to clone or just download the tutorial code that we will go through together. So I'm going to give you some minutes to get this installed on your environment. And if you have any questions along the way, just ask them on the platform that we used earlier. I'll put the QR code in a minute. For installing the Scripto toolchain, you can just follow this link, go to the Radix DLT-Scripto repository, and read the README, and you will have installation instructions for Windows and Linux and Mac OS. So the first step is to install Rust. And if you have any
let me just ask real quick. We'd sent these instructions out to people before the conference here. Can I get a quick show of hands of like who's already done this? All right, so we're pretty solid here. Good job, guys. Let's get into it.
Yeah, okay. So for the first example, you will learn the basic structure of a blueprint, how to create a token, and how to use the command line tool resim to deploy the blueprint to the local simulator, and how to test it by calling methods on the component. So the diagram on the top right shows how it will look like. So the blueprint will have a instantiate hello function that when called, it instantiate a component. And then users will be able to call the free token method on those instantiated component to take a hello token and get it back inside their account. So open up the first directory, 1_hello world. And if you need instruction along the way, just follow the README. It has all the instruction to run this blueprint. So the code is stored inside the lib.rs file, inside the src folder. So if you open up this file, you will see how a blueprint looks like. So the first line is where we are importing the Scripto module, and this gives us access to types such as buckets, vaults, and resources. Next, we declare that we are creating a blueprint with this blueprint line. And a blueprint consists of two parts. The first one, the struct, is where you define the variables that will be present in each of the components' state. Next is the actual implementation of the blueprint. This is where you are writing the code, so your functions and your methods. We have a function called instantiate hello, which returns a component. And when you look into this function, you can see that we are creating a fungible resource. And we do this by calling the resource builder, and we specify a divisibility for the token. In our case, we put the constant divisibility maximum, which equals to 18. And this means that we can move this resource around with up to 18 decimal places. Next, we define some metadata for this token. We provide a name and a symbol. And then we want to initialize it with a supply of 1,000. And this returns us a bucket. And we store this bucket inside this variable called myBucket. And the final step we need to do inside this function is to instantiate the component by providing all the variables inside the state. In our case, there is only one called sample vault. So we define it by saying vault with bucket. So this instantiates a vault with the buckets. So in our case, the bucket contains 1,000 resource, so it will insert them inside the vault. And this is, because this is Rust, you can actually omit the return here and simply write the statement and remove the semicolon. So this will return the component.
We've got a request from the streamers is that we increase the size of the ID a little bit.
Okay. Like this. And so we are now done with this function to instantiate a component with a state. Now we are going to define the method allowing users to get a free token that is stored inside the sample vault. So we write pub fn and the name of the method, which is free token. And notice that it has a parameter named self. And this refers to this allows us to access the state of this component. And this makes it a method and not a function. And we define it as mutable with the mute keyword because we are actually going to update the sample vault by getting a token from it. So inside this method, first we do some debugging. We write the balance inside the sample vault with self.samplevault.amount. And then we are taking a single resource from the sample vault, and we are returning it as a bucket back to the transaction layer. So this is all we need to do to write a simple blueprint. So now we are going to be testing it. So open up the terminal at the bottom of the screen. And all the instructions for running is in the README. So we are going to be using Resim to create a default account, publishing the blueprint, calling the instantiate hello function, and also calling the methods. And all of those calls will be generating addresses. And instead of having to copy and paste all the addresses around, I've provided a simple script that is putting all the addresses inside your environment variables. So before running anything, if you are on Linux or Mac, you can do source var.sh. If you are on Windows, simply run Windows, the command prompt, not the PowerShell, run the var.bat script. So this will allow us to reference to addresses using variables. So the first step is to call resim reset, just in case you already played around with the code and you instantiated things. So this will remove all the created accounts, all the published packages, and reset your environment. Next, oh, and by the way, there are instructions for Windows at the bottom of the README. I am on a Mac, and the simple difference is how you reference the variables. For example, on a Linux and Mac, you put the $sign, and on Windows, you have to put the %sign. After resetting the environment, we are going to be creating the default account from which we will be calling the components with resim new account. And this returns you the address of the account and its public key. We can do things such as resim show, and we can reference the address, account address with $sign account, or if you're on Windows, using the %sign. And this will show all the resources that are stored inside this account. And as you can see, the account starts with a million XRD token. This long string here is this is the address of the resource definition of the Radix token, and we will use it later. So now that we have an account, let's build our blueprint that we just saw and deploy it on the local simulator. We do this by doing resim publish, and we provide the directory, which is, if you are in the hello world directory, it's dot. So now it is building. And you should get a success message if everything went correctly. And you should also have the address of the package that you will use to call functions on the blueprints that are contained inside it. And this is exactly what we will be doing right now. So we want to call the instantiate hello function. Remember, this is the function that we defined that creates the component and returns it. So we call it by doing resim call function. We provide the address of the package, which is stored in the package variable. And then we need to provide the name of the blueprint that we want to access. In our case, it's hello. It's the name that we provide in the struct and implementation section. So we write hello as the next parameter. And next, the name of the function we want to call, instantiate hello. So this should return you a success message along with new entities that were created along when calling this function. So you can see a new resource definition. This is the address of the token that we created, the hello token. And we also have the address of the component. We need the address of the component to be able to call the free token method on it. To do this, because it's a method and not a function, now we will use resim call method instead of resim call function. We provide the address of the component. You can either copy and paste this address or just use the component address or the component variable. And then the name of the method you want to call, so free token. And next, this command accepts, allows you to provide some parameters, but in our case, as you can see in the code, the free token method doesn't have any parameters, except the self, which is automatically added. So we just call this command like this, with no parameters. So you can see a success message, and you can see the debug text that we provided inside the info macro. And it shows that it has a 1,000 hello token, and that's because we are taking one after writing this to the console. So let's call it a couple of times, and you should see the number decrease every time you are calling it. So now, if we do resim show $account, this will show us, again, this will show us the resources stored inside the account. And you can see that you have received now some hello token. And in my case, I called it 9 times, so I have nine resource of hello tokens. You can even do resim show and with the address of the component that is stored inside the component variable. And now you can see that they are it was started with 1,000 resources, and now there are 9 less, which is what we are expecting. So this is the basics of creating a blueprint, building it, deploying it, and testing it. And so, do you have any questions? I'm going to go over to the slido.com so that you guys can ask questions. You can also vote for your favorite questions to make sure that they are answered.
So where we're at right now, it's about 5 past 12. We've got lunch planned to start at 12:30, so we've got about 25 minutes. Basically, we're kind of in open working until then. So we're going to be available for questions. Of course, we can also answer questions during lunch. So I think we'll keep working. I might hit some of the other questions I think from this morning, but yeah, I mean, if anybody has anything, get it in Slido, and we're just going to be doing stuff for the next 25 minutes or so. Yeah, do you want to go ahead and start hitting some things, or? Yeah, sure. We can just go to the top of the list, and I'll start doing some stuff. How braided sharding works. That's it. You want to spend the rest of the day on this one? I'll try to give the elevator pitch for braided sharding. Really interesting mechanism, and if you want to get the real answer, that you should read the Cerberus white paper that's on our webpage for sure. Concept of braided sharding, and certainly I'm not going to convince you that this is a good consensus mechanism, but the concept is that we have a pre-sharded ledger. So rather than you've heard of sharding, typically the idea is like, well, you start with kind of a limited number of shards, and maybe you add to the shard space as you need more capacity, so you can get more parallelism. We kind of go to the other extreme. We're saying if we want to have the level of throughput that we need for this kind of ledger, we start with an infinitely, not infinite, but a virtually infinitely sharded pre-sharded space. So basically, deterministically, you can map anything that needs to happen onto the network to a shard somewhere in shard space. And so you basically can get as much parallelism as you want forever. If you're going to take that approach, now when you come back to consensus, you need to figure out a way of saying, well, for a given transaction, I need to get a way to be able to coordinate. I need to be able to temporarily pull together these 3 shards to be able to do something that's related to all 3, do consensus on those things, and then turn those shards loose again. That's what the braided sharding is. So it's basically it's a 3-phase hot stuff like BFT consensus mechanism that braids together the phases of consensus across multiple shards, ensures that correctness is guaranteed across the relevant shards for a particular transaction. And this gets even to some of the Radix Engine stuff. Radix Engine is designed to express its state in terms of these particular shards and the relevant updates that are required to state on those shards. So the braided consensus mechanism, I'm not going to try to describe how it works, but that's what it means basically, is connecting consensus across an arbitrary set of shards. Why Rust? That's a good question. I will say that definitely the Radix Engine concept, even the Scripto concept, predates the selection of Rust. Rust was kind of one of the last decisions we made about it. The starting point for it was like, we got to get this asset-oriented model, and kind of like we were thinking conceptually about how should this thing work. It was like drawing the diagrams. It's sort of like, what are the things in the system, and how do you connect them together, and how do you create transactions, and thinking about, well, if I wanted to build these things that are in DeFi today, how would that express in this model? So a lot of that was very conceptual for a long time. And then even when we got to, okay, how do we turn this into Scripto syntax, and how do we want people interacting with these things? We were thinking at that point about a bunch of different options for the language, everything from like Java to C++, and you name it. Rust in the end won out because it has some very nice built-in notions of ownership that it uses that sort of we could expand those existing notions in Rust to really nicely map to notions of asset ownership in the Radix Engine model. And so we just found that the additional syntax that we had to add to create Scripto sort of naturally fell onto Rust. We didn't feel like we had to invent whole new concepts. It just mapped very much in the view that Rust has on the world. And then on top of that, we've just been very impressed with Rust. Rust is just like a really cool language, very flexible, very clear, very expressive. So yeah, that was one of the selections. That isn't to say, I mean, it's possible to do anything. Scripto could be re-implemented in any other language as long as it provided the right primitives to translate down to Radix Engine 2 versus base state, but we feel like Rust is such a really natural model that we're pretty well committed to it. In fact, it's maybe even changed some of our development roadmap. We're thinking we're going to be starting doing some of our internal development in Rust just because we're so impressed. The plans for adoption on web platforms. We're delivering a JavaScript module. We let the community build that. We are going to build there will be a JavaScript SDK that we're going to make available for web developers that would allow you, the thinking right now, this is a little preliminary, but it's pretty much what I think we're pretty sure this is what's going to happen, is there's going to be a separate wallet API and gateway API. So wallet API is, this is how I push stuff to the Web3 wallet. Gateway API is, this is how I talk to the network directly. Both of those will have their own specific API, and both of those would need their own JavaScript SDK for web developers. So we would plan on building that for sure. How do Scripto contracts interact with the outside world data? How to use Oracle's concept? That's an interesting one. I'd say the Oracle concept isn't too much different in Scripto world. It's pretty much the same. Generally speaking, I guess the core Oracle model is there's some sort of system off ledger which has some data, and maybe it's a consensus network itself, maybe it's a centralized system, but one way or the other, it needs to make that data available on the network to other components in our case. So what we would have is have an Oracle component that is set up to receive that data, basically, like the off ledger system. We can be a little bit more clear about how you authorize into that because of our cool badge-based auth model, but basically your off-ledger system could authorize to the Oracle component and update a list of prices or whatever you need. And so, I expect that, I think there's already some Oracle blueprints that people have been building. It's that part of it is pretty straightforward. And we're looking at integration with popular Oracles as well. Chainlink we have a partnership with that we're working on with them on. So I guess the other part of it is the request part of it, of saying, like, telling the on-ledger component, here's a piece of data that I want, and that's a matter of that component sort of registering the request internal to its own state such that the off-ledger system can see that, fulfill the request, and then this gets passed back to the component. So if you're familiar with the way it's done on Ethereum, it's pretty similar, but you get to build it in Scripto code, so it's a little bit cleaner. What do you mean by assets built into the smart contract platform? Are there different standards similar to ERC20 or ERC721? Right. So I guess if this was answered this morning, hopefully this is a little bit more clear after the second presentation. I forget if this one came in. Was this one that came in this morning? Yeah, okay. So hopefully I've answered that one pretty clearly right now, but I guess I can emphasize it a little bit. The idea is that no, there is no ERC20 or ERC721. The idea is, what we found is that there are these basically universal notions of physical asset behavior that we can translate into this set of platform-delivered flags, or it's going to become something a little bit more flexible than flags. And as I said, we spend a lot of time going through use cases and making sure that there's not just a way of implementing something people are doing on Ethereum, but actually a really elegant asset-oriented way. In fact, a lot of times we find that building it the asset-oriented way, it takes a different form than you might be used to. Like if there's a special ERC standard, it might not be directly mapped, but in the end, it's actually provides you nicer guarantees of behavior. So there's actually an interesting point here, because I think one of the issues with the whole ERC, the set of ERC20 standards on Ethereum, is that because of the smart contract structure they have, there's a sort of natural draw to build a lot of logic into those ERC standards. It's like the NFT standard isn't just about the NFT itself. It also sort of builds in, like if you like, CryptoKitties, for example, like the game logic is built into the token smart contract, because naturally that's sort of how you want things to be. If you have to implement everything as a smart contract, there's a tendency toward these monolithic contracts. And the problem with that is it doesn't make things very flexible and modular. Like you end up with this standards, like this is why you get a proliferation of standards, because you say, well, okay, there's this whole new application area, so here's a new ERC standard, and then we realize, oh, but actually it lacks this other thing that someone else needs. Okay, now we need another ERC standard. In our case, what we found is we keep to this very simple set of flags, but we clearly separate the asset behavior from the business logic, essentially. So if I'm building CryptoKitties, I don't build CryptoKitties logic into the token. I issue a token that has the behavior, the core behavior that I want, and I might, for example, give authorization to do certain things with that token to a component that I would write, and that component would implement the game logic. So now the game logic you can get as elaborate as you want. It's completely flexible in Scripto, but in the end, that component can reach into the CryptoKitties token, and maybe it's the only thing that has rights to update the NFT data on the thing, or maybe it's the only one that has the ability of allowing the user to transfer it from place to place. There was another concept that someone was asking us about, which was, what if I want an NFT where the creator of the NFT gets a fee every time it transfers from wallet to wallet? that gets built into the ERC, it's not a 20, but an ERC contract today. In our case, what you do is basically build a clearinghouse component. That clearinghouse component needs to produce a badge that allows transfer of that asset. And if you want to transfer that asset, well, in the transaction manifest, you got to make the payment to the clearinghouse. Then the clearinghouse goes, cool, I'll present the badge, and now the asset can be transferred. It maps much more directly to how this actually works in the real life. We don't have, if there's a piece of art that needs to have a fee associated with transferring it, you don't build that into the piece of art. You just have the object, and then you have a separate clearinghouse that manages that sort of business logic. So this is the philosophy of how we do things. If you deploy a package, will all blueprints automatically be open source readable? Yeah, this is a complex question. Yes and no. So blueprints do get, and packages do get deployed to the network in compiled form. But there are two things that, I guess the short answer is pretty much it's open source, and this is kind of the nature of an open ledger, is that code kind of has to be open source. So, this kind of makes enterprise uncomfortable with public ledgers, but I kind of feel like this is the nature of decentralized finance. I would say that on one hand, the standard of behavior today on these open platforms is that, and I think it's a good standard behavior, is that if you have a piece of smart contract logic on the ledger, if you want people to trust that, it really should be open source. Now, that doesn't mean that all of your off-ledger stuff has to be open source and your UI logic and things like that, but the core of the thing that's managing assets and doing all this stuff in terms of ownership, like, that needs to be open for people to be able to really trust that it's not going to be doing something kind of funny behind the scenes. And so generally what people do on Ethereum is there's the compiled code that goes to the ledger, but they are typically posting the source code behind that, and they're like Etherscan does this, they're various services that basically will prove that the uncompiled code matches the compiled version on the ledger, so you know that, okay, I can trust this code. So I think something similar will happen with Scripto as well. The other thing is that ultimately we can't stop it. The compile, WASM will pretty trivially decompile, so you'll miss your variable names and whatnot, but ultimately you can recover the logic from the compiled form. So pretty much the answer is it's going to be open source. Main difference between building on Radix networks versus others versus Solana and Terra? I think I've answered that one pretty clearly, although I'll make one point particular about Solana because I think it's interesting. I think it emphasizes the fact that the language choice isn't everything, because Solana uses Rust as its programming language. I definitely encourage you after you go through today to think about, I think they even have an piece of example code on the Solana webpage. It's not a gumball machine, but it's very similar to the gumball machine. It's something where it's like you put a token in, you get a token out. I forget what they call it. Compare the code that you write in Rust in Solana to do that, and compare that to the gumball machine we're going to look at today. It looks nothing alike. It's completely a different universe. Even though it's all basically built in Rust logic, the Solana version is very difficult to read because you have no notion of assets to leverage. You don't get to stand on those shoulders. In our case, you get to stand on the shoulders of this basic asset-oriented model, and so the code is much more direct. So we've had some people be like, well, is Scripto really language, or is it just sort of a framework for Rust? It's like, formally you're right, it is a framework for Rust. The reason why we feel okay at calling it a language is because the actual experience of writing code and the resulting code that comes out for DeFi looks nothing like Rust itself would suggest. You're spending most of your time interacting with the new features that we brought to it, and Rust is providing kind of core syntactical notions that we leverage. So it's a very, very different experience than other platforms, even if they are using Rust. Does Scripto intend to become a multi-chain development tool? Not intended to be. That said, we're not opposed to the idea. It's open source. Scripto is open source. People can do whatever they want with it. I will say that there are a lot of, again, this is probably clear by now, but there are a lot of assumptions in Scripto. There's a lot of stuff you need below the Scripto layer in order for Scripto to be possible. You wouldn't be able to just drop Scripto onto the EVM. You would have to implement a new virtual machine that knows how to speak in terms of assets and then made Scripto up to that. So in concept, sure, the language could be used elsewhere, but you'd have to build a platform that basically also implements the Radix Engine. And then the Radix Engine, in turn, is built in a very integrated way with our Cerberus consensus mechanism. So we have this very integrated stack such that you basically would have to rebuild Radix to be able to get access to Scripto in the end. So the answer is, generally speaking, no. It's not intended to go across platforms because it kind of can't. What are some adversaries to Cerberus and why is Cerberus superior? I guess you mean competitors, like other consensus mechanisms. I don't know if I want to get deep into this. I mean, I'll speak, and this will probably be frustrating for whoever asked the question, but I would say the resulting benefit is that compared to other high throughput consensus mechanisms that are being proposed today, the aim of Cerberus is not to deliver a certain transactions per second number. Basically, the driving design requirement of Cerberus was unlimited parallelization. Parallelization is the solve. You're trying to build a global ledger where you're going to have millions of people, thousands of applications running at the same time. Essentially, no fixed. It's like trying to apply. It's like trying to say, you know, if you're designing the internet, you're trying to design TCP/IP. It's like, well, we need an internet that can do so many packets per second. It's like, no, the point is you just need a network that can be expandable, unlimited, and you've got parallelism. So we're taking the same approach basically for assets, where most things that happen on the network won't be related to most other things happening at the same time. So why are you trying to cram it through the same pipeline? Even if it's a very fast pipeline, it's going to hit a limit at some point. So we've designed everything from the beginning around this idea of unlimited parallelization, and that drove the design of Cerberus. And so ultimately, in effect, our belief is that Cerberus will provide more effective throughput through parallelization than anything else that we're aware of. Something you want to jump down to? Yeah, go ahead.
Yeah, I think I can answer some questions about what we just coded.
Cool.
We have a question. Can each blueprint have more than one method and or function? Yes, and we will see examples of that in the next sessions. So in the example we just saw, when the component is instantiated, is Alice the account who is minting the token into a vault? No, it's actually the component that is that is creating the initial supply of the tokens. When can we access the full source of Scripto? It's already available on GitHub under the, right here, the Radix DLT-Scripto repository. Where can we learn the full course of Scripto for free? There are multiple resources that you can use online to learn more about Scripto. We have the documentation, we have code examples on GitHub made from the community, and we also have code examples made from the Radix team.
Can I get a microphone? There we go. The other thing I'll think is we're also starting to work with some web pages that provide educational courses for various programming languages. So we're starting to work with some of those, and we're going to try to get Scripto courses created around this stuff as well. In fact, you know, if anybody in the room here, I mean, we're all about community, as I talked about this morning virtually. You know, if people have connections to whatever it is, you know, programming groups, universities, online systems, you know, anything where there is educational material being produced and presentations being given about things, we'd love to work with you. We'd love to figure out a way of working with those organizations, with you, to enable, you know, getting more materials out there about Scripto.
We have a question about, because there are no ERC20 or ERC721 standard, is there a way to transfer tokens to other chains like Ethereum that follow those standards? The answer is yes, and actually we are already doing it. We have on the Radix main network, we have the XRD coin, and we also launched the EXRD token on Ethereum, and we have a bridge that allows, that it's called InstaBridge, that allows people to bridge from from EXRD, which is ERC20 on Ethereum, to the Radix main network.
Yeah, and this is, you know, it follows the general pattern of bridging that happens on other networks as well. It's the idea that, in the end, these two networks can't verify each other's state clearly. They're different consensus networks, but there are various forms of bridging system that allow you to lock tokens on one network and then release equivalent tokens on a different network. So InstaBridge that he mentioned is a system that allows you to do that through sort of a custodial system, but then you'll see other networks have sort of network-enabled mechanisms of doing these sorts of things. So we're going to be pursuing more of those bridges in the future.
What is the easiest way to apply for a job? This is a question for Farah that she might answer later.
Yeah.
She'll happily talk to you. If anyone wants to talk to Farah. Farah's in the red.
Yeah.
Yeah. She'll happily talk to you.
And we are hiring. Yeah. Talk to Farah. She's in the room here. And also, if you go to our webpage, we have a career section where we're doing lots of hiring right now. So love to talk to you.
Are components immutable after deployment? And how would I deploy a faucet and Scripto? So yes, components are immutable, but in the future we will be implementing a versioning system to be able to update your blueprints. And how would I deploy a faucet and Scripto? Well, the example that we went through is a little bit like a faucet, in the way that you can request free tokens from it. But a feature that would be nice to add is a way for the admin to insert more tokens inside so that it doesn't reach zero. Another question, what is the difference between buckets and vaults? Buckets are used to transfer resources around in a securely manner, but they can only exist in between transactions. At the end of a transaction, the content of a bucket must be inserted inside a vault. This is to make sure that no resources is lost along the way. For example, if a developer forgets to actually store the bucket somewhere. So I guess we can take a break before we get to the next session.
Yeah, I guess we got. What, 1? Oh, I thought it was 12:30. Are we doing lunch now or doing it at 1 o'clock? Now? 12:45. So we got another 15 minutes. Okay. All right. I guess I can hit a few of these. Having a figure like a bank gives us security. Why would people take the risk? How do you intend to solve this possibility? Well, that's a big one. It's a mind shift. I mean, this is the long road of DeFi. I think you have to start by not, put it this way: no one ever gives up convenience and security for new features. This is something this is my opinion anyway. I think you can come up with something that's super cool and you can do a bunch of stuff with it, but if you had to make a compromise, it's like, well, this is harder to use than the thing I had before, or it's not as safe, no one's going to adopt it. And that gets to what I was saying this morning about this is, I think, a major reason why people are not adopting DeFi today is that if they've even heard of it, their first experience with it is like, ooh, I got to write down a 16-word seed phrase, and if I lose this thing, I lose my money, and this user interface is weird, and it's very confusing to people, and so this is why I don't think you see a mass migration to it. So I think step one of providing this feeling of security is don't force people to give up their expectations for these things when they come into DeFi. And this gets into not only the platform, but it also gets into like the wallet and all sorts of other things. So this is something that we've been putting quite a bit of thought into. I think as an example, things like being able to clearly see asset behavior and show that in the wallet, and being able to clearly see what transaction is going to do in the wallet. That gives us at a platform level, it gives us the tools we need so that when we build a wallet experience, we can start to replicate what people are expecting from the traditional banking system. In some ways, the bank experience isn't broken. What's broken is behind that. It's the fact that I have to have a bunch of different bank accounts, or maybe I can't even get a bank account, and what they offer to me isn't very good, and the rate of returns, what I get from my bank account isn't very good. That's the stuff that needs fixing. So I think our goal, generally speaking, is being able to replicate the feeling of, a mainstream level of familiarity with the system and sense of security so that they can get access to the benefits of the DeFi system behind it. So I know I'm just stating the problem, not the solution, but I think it's a combination of platform features and the wallet experience that we build in front of it. You want to do that one?
How would you prevent the use of the bucket as a bad vault? I don't really understand this question. Maybe try to rephrase it.
People are worried about spamming of tokens to vaults that people don't particularly want to hold money.
I think that's a different question. I saw that one about the honeypot, but we're talking about the first one up here. Yeah, I think that's the one you're talking about. Go back. I mean, to answer the question, buckets do have a lifespan. So it's the duration of a transaction. So any operation on the network starts with a transaction. There's a transaction manifest that gets handed, and then that kicks off some action. So the requirement of the Radix engine is that any buckets that get created in that transaction have to be empty or they have to be destroyed by the end of that transaction. You can't have any tokens where, for example, if I had a component that put some tokens in a bucket and returned that, but then the transaction didn't do with it, it didn't deposit them somewhere else, then the transaction's invalid. At this point, the Radix engine says, nope, that's not going to go through because I must guarantee the transactions are held someplace. There needs to be an explicit resolution of all the assets in that transaction. This is part of how we guarantee this behavior. In fact, in the transaction, you can actually add in asserts to the transaction as well. You can sort of put extra limitations in there to say like, I need to make sure that I get at least this many tokens out of this thing for this thing to be valid. So anytime that gets validated, the entire thing doesn't happen. So there's no way that you could use a bucket as a bad vault. Syntactically, they operate as different things, and there's no such thing as putting something in a bucket and not resolving it.
We have questions about badges, and can we elaborate? So in the afternoon, I'm going to go over what are badges, how to use them. But basically, they are the way we do authorization and authentication of the users that are using your component. So instead of having the ID of your identifying your user by their address, we are using the resource-oriented model of Scripto by actually giving them badges that they have to present in order to do certain actions. But I will go more into that later.
They're really cool. Love badges.
So where would you see Scripto main use case? It can be used.
Let me do that one.
Yeah, go ahead.
Because it's interesting, the main use case. I mean, in the end, I think, as you can see, Scripto and Radix Engine were really built around, the way we express it is finance applications. Like, to me, the main use case is DeFi. But I want to explain what I mean by that a little bit, because I think it's easy to think of like, well, okay, particularly if you're in the crypto space right now, you see DeFi as like, what's going on Ethereum right now? It's sort of like, oh, okay, you've got these lending and you've got some of these things that are going on. We take a very, very expansive view of DeFi. When we say DeFi, it's really just anything that has to do with interacting with ownership, interacting with assets. If you want an application that's just purely passing messages around, there are no assets at stake in that, I kind of question your use of public ledgers in general, not just Radix. Like, I generally don't see a lot of value in those things. There probably is some edge cases, but really we've built Scripto around those things. Now, you can use Scripto for anything. I mean, it's every bit as expressive and powerful as Solidity or anything else. So we haven't sort of designed Scripto to narrowly focus on a particular application at the expense of other applications. But I would say that the particular emphasis we put in is providing the tools to build anything that has to do with exchange of ownership, identity, and all these sorts of things. And really, this gets into, there's this overall feeling, I think, that a lot of people in various technology industries see happening. There's this migration towards some sort of concept that we've got different names for. It's like you call it DeFi, you call it Web3, you call it the metaverse. Like, it's all kind of in a certain direction, and this all has to do with like, I think the common notion of the thing is like we need native digital representations of real value and real identity. And that's kind of what we mean by DeFi, is like there's all these really cool things that wrap around that. So when we say finance, don't think of this as purely, well, we're re-implementing Wall Street on a public ledger. It's like it gets into, finance, every bit as relevant to finance is like, I want to build a game where the sword you win in the game is not just something that exists in the game. It's actually an asset that you can hold yourself, and you can give it to someone else, and you can trade with other people on directly on this ledger. It has to do with an enormous number of things that are outside what we call traditional finance. So, I know it's kind of a non-answer to say it's designed for everything, but like it's really about this digital ownership, which I think is an incredibly powerful concept.
So we have questions about if we have a smart contracts library like OpenZeppelin on Ethereum to accelerate the development. We have something that we think is better. It's the blueprint catalog, and it's like a way to share your blueprints on Ledger, and where people are able to use them easily without having to re-implement the feature. They just call the blueprint instantiator function, so they not unlike Ethereum where they have to duplicate the functionality over and over again.
Yeah, imagine if you had an open Zeppelin, but for each one of the listings there, it wasn't just here's some code you can use. You'd say like, you can just programmatically ask for one of those without having to pull the code in a place. And you can see, oh, there's already a bunch of things that are using this code, and you can see how they're operating. The other thing I'll throw in here also, though, is that if you do want open source code to work with, particularly now when we don't have the public ledger and we don't have a blueprint library on it, well, we do have a community GitHub repo, which probably is linked to in your materials. But that community repo is something that people in the community have been contributing to. There's a lot of really cool examples in there. We've been running some challenges. We just finished up with a challenge for decentralized exchanges. We got 10 really interesting examples of how you might build different forms of decentralized exchange. And this is all in our open source repo that you can look at. Great examples there.
So we have another related questions. So our package with the blueprints and everything like are those like a package manager like NPM, Pacman? So this is, again, the blueprint catalog. The blueprint catalog will be like a package manager, sort of. Can vaults be told to hold specific buckets? Not specific buckets, but when you're instantiating a vault, you are providing the resource that this vault will hold. So whenever you try to insert another type of token, you will get an error.
Yeah, it kind of goes the other way. It's not as if the vault blocks specific buckets. It's the vault can only accept one particular type of resource, just like a bucket. This actually is relevant to, I can't remember what it was. There was a recent exploit that happened on Ethereum, and I can't remember the name of the thing. But basically, it was a system that was a bridging system where there was an expected asset that needed to be sent to the smart contract, and then on the other side, on a different network, it would kick out a wrapped version of that thing. And someone figured out a way of basically creating another token smart contract that looked a lot like the one it was actually expecting, and basically sent a fake token into the bridging service. And the bridging service, basically, there was a sequence of checks it needed to do. It needed to kind of look at the smart contract and kind of go, okay, this and that, to make sure it was really the token it was expecting. And basically, they overlooked one of the checks, and then some ridiculous number of millions of dollars ran out the door as a result. So in our case, it's like you can't do that. For example, if I had a bridging smart contract and there's one token I wanted to accept, I would create the vault for that particular token type with its address, it's unique, and thereafter, I didn't even have to do checks at that point. I could just have my bridge sitting and say, yeah, send me whatever you want. Okay, here's a bucket of this. I try to put that in there. Doesn't work. Okay, I guess that wasn't the right type of token. Transaction fails, you didn't have to worry about it. If it's the right type of token, it goes into the vault. You can rely on it.
So another question. In the last example that I showcased, the state of the component only contained a vault. So the question is, can we store other types of values? And the answer is yes, and we will see examples of that. A question about the validators?
Yes, we do have plans for further decentralization of the network. So the Olympia network right now that we have, which is what they're referring to with the 100 active validators, the current form of network that we have uses a very simplified form of Cerberus. So it is not sharded. The current network is essentially a single shard. And the BFT consensus mechanism we use for that has a fixed validator set right now. A number was sort of, the 100 number was a compromise between getting a sufficient set for security versus expanding that set too far basically slowed the network down on a single shard. Now, our whole point is with sharded, braided Cerberus consensus in the long term, that whole problem goes away. If we have an unlimited number of shards, then we can be much more flexible. And now the validator set is no longer fixed at 100. It's essentially as many people as want to participate can be a validator in this thing because we'll have all these shards that you can participate on. So definitely that will be a huge step up in terms of decentralization at that point. Once we get to Xi'an. Until that point, there's really not a lot we can do. Sort of the consensus mechanism has to move to this sharded model for us to be able to raise that limit. So that's why for now, for the sake of people that are following Radix as it is right now, we've been very, very aggressive about ensuring and encouraging broad community control of that validator set. So we're operating a couple of validator nodes with a little bit of stake behind them, but basically since the beginning of the network, it's been community operated, and we have a really, really cool community validator set. They've got their own channels. They're enforcing standards on each other in terms of like high quality node running. They're doing a great job of building a welcoming community around high quality network operation.
So how would royalties work if it's all open source? This is a question we get a lot from the community. Can you answer that?
Yeah, let me punt this question. Like, I understand what you're asking. Say, well, it's all open source. Who's going to pay for it? Like, it's a complicated answer, and the answer isn't sort of a direct. Well, we can guarantee that if you copied code, then the system's going to know that happened. Like, it's characteristically what we're trying to do is build a system where good actors can do the right thing, and I think there are a lot of really good examples in the world where that works really well, and I think it can work here as well. Yeah, it's a very long answer to this one, and it's something I'm sure we're gonna be talking about more. But it's, I think a key to the system is building a system where you can accumulate reputation and you can accumulate a reason for other developers wanting to support you. Can someone else copy your code and redeploy that to the network and then charge a lesser fee? Yeah, they can do that. But I would expect that the developer community and a user community is going to see that as bad behavior. You're being a jerk. Like, clearly we can see that this was there, you deployed this thing later, and you tried to undercut this guy. And this guy over here is providing regular updates. He's the original creator. He's built 20 other components that are working really well. Like, why wouldn't I pay? And if I'm choosing to integrate with one component or the other, why wouldn't I choose to be willing to pay a small royalty fee for that guy to get access to all that other off-ledger stuff, essentially? It's about, again, it's kind of about community. So it's, there's no hard technical answer to this, but, I think we've seen other examples where giving a community the tools to do the right thing can work out really well.
One more question.
Yep, one more? Okay. So when you want to grab?
Maybe the most popular. How do you plan to protect against flooding the network? Most low-fee and scalable chains are having issues lately.
Yeah, so two parts to this answer. So part one is Babylon network, the next one, and part two is Xi'an network after that. So Babylon is where we first deploy Radix Engine and Scripto to the public ledger. That's going to have the same underlying consensus mechanism as today, so it'll still be single sharded. Xi'an is there, of course, when we shard that. So on Babylon, we are going to have a form of bidding mechanism where it's not a fixed low fee. It's like if the network gets into a congestion state, then you'll have the ability of prioritizing transaction based on, it's like, well, I'm willing to pay more to jump to the front of the line. It's kind of similar to Ethereum, although the way we're doing it is different because I think Ethereum, the way they do it introduces a lot of volatility in that bidding. It's sort of like people bid even though they really didn't need to, even though the network wasn't at capacity. The capacity that we expect to have for smart contract operations, even at Babylon, we think is very competitive. Like Ethereum is basically like 15 transactions a second. Solana, even they claim thousands of transactions a second. When you actually look at, like throughput on a decentralized exchange component, it drops down to more like a couple hundred transactions a second of realistic smart contract throughput. So we're at about 50 right now. We're looking at some optimizations that might increase that sum, but basically this is multiple times what Ethereum is doing today, so we have at least an advantage in the near term in terms of maximum throughput. I think if the ledger gets to the point where we do have a congestion situation, this bidding mechanism kind of provides a nice, elegant way of continuing to make progress. But basically then when you get to Xi'an, this is where the taps open. It's sort of like, all right, now the problem, I'm not gonna say it goes away, but at this point when you have unlimited parallelism, what this means is that if there's a huge amount of demand for network, all this, that rather than requiring you to pay more to get your transaction through a limited pipe, now what this is doing is it's incentivizing more people to join the network to provide more parallelism. It basically becomes a business opportunity for someone to say, oh, I want to run a node now because it looks like it's going to be valuable. So the mechanisms will change quite a bit at Xi'an.
So we are going to take a break before going to the next coding session.
Yep, sounds good. And yeah, if anybody wants to grab one of us and pull aside over lunch, it's not rude. Go right ahead. All right, time to eat.
Hey guys.
So how was lunch? It was great, right? So for the next part, we are going to be building something a little bit more complex than the previous example that we worked on. Now we are going to be building a gumball machine, and this will teach you how to parameterize your blueprint so that people can instantiate components from it with different parameters. So this will show the power of the distinction between blueprints and components. You will also learn how to accept a payment from a user, because the user will have to send some Radix tokens to the component to be able to get back a gumball, just like a regular gumball machine works. So you can see how it will work on the bottom diagram. So 25 XRD inside a bucket is sent to the buy gumball method. Then we are taking a gumball from a vault containing gumball resources, and we are giving it back to the user. So let's get into the code. Open up the second example and go into the lib.rs file. And you can already see that it gets a little bit more complex than the last one because we have more variables inside the states. We have, for example, we have a vault that will contain the gumballs that we will initialize the components with. We will also have a vault to collect the XRD that the users will be sending us. And we will store the price that the component instantiator will be providing. Now for the instantiate machine function, this is the instantiator function. So it will create the component and return it back. You can see that it accepts a price of type decimal, which the caller will be able to provide. And the rest of the function looks just like the last example. So we are creating a resource. Now, instead of being hello tokens, it's gumballs. So we change the name and symbol. And we create an initial supply of 300. And we are, again, storing it inside a gumballs bucket. Next, we are defining the state, each variables that the components will have access to. So the gumballs, it's just like the previous example. We do vault with bucket because we already have a bucket of gumballs. For the collected XRD, it's a little bit different because we don't have a bucket. We only have, we only know the address of the resource that we want to store in it, in our case, Radix tokens. So instead of doing vault with bucket, we can do vault and call the new function on it. And we can, we have to specify the address that this vault will contain because remember, a vault can only contain a single resource type at a time. And Radix token is a constant that is provided by Scripto just to easily represent the Radix token address. And finally, we specify the price, which is just the arguments that was passed to this function. Now for the method by gumball. Again, it requires a mutable reference to self because it will be updating the state of the component. It also needs a payment bucket. This bucket will be provided by the user. It needs to be mutable because we are going to be taking some tokens from it. And notice that it returns two buckets. The first one is the gumball that we are returning, and the other one is the change. I'm going to go more into why we do that after. Next, inside the method, we are outputting some information. We are just writing buying a gumball. This will be useful for a later example where we're going to do composition. Next, we want to take a portion of the payment bucket depending on the price that was provided on instantiation. So we do payment.take, and the amount that we want to take is self.price. And this returns a bucket, and we store it inside the our share variable. Next, we want to store this our share bucket inside a vault so that we know that the tokens are securely are stored in a securely manner. So we are inserting it inside the collected XRD vault by doing self.collectedXRD.put, and we provide the bucket, which is our share. Next, we want to take a gumball to return it to the user, and we can do this simply by calling the take method on the gumball's vault, and we want to take only one gumball. And again, we store it inside another variable. And finally, we return the gumball, and the second bucket is we are returning the payment. Why are we doing this? Is because just in case the user sent more than the required amount. For example, if the price was 25 XRD, and they decided to send 30, Here, when we take 25 from the payment, 5 XRD will be left inside the bucket. And the Radix engine doesn't allow a bucket to contain resources at the end of a transaction, just to not lose those tokens. So you actually need to return back the change to the user. So in my example, if you send 30 instead of 25, you will receive back 5 XRD. So that's it for the code for our gumball machine. So we will go inside the README file and try to run it. Now, I saw a lot of comments in the community asking questions about, because it was not working on Windows, the environment variables. So if you're using the PowerShell, it won't work, because the way you create environment variables and refer to them is a little bit different than using the command prompt. So I suggest, if you're on Windows, to use the command prompt instead of the PowerShell. So go into the terminal at the bottom of the screen and change directory to go to the second example. Next, like the previous example, we are going to generate a lot of addresses for the component, blueprint, resources, and we don't want to having to copy and paste those addresses around. So you can call the var script, which will create a lot of environment variables that you will be able to use to refer to addresses that are created. So if you are on Linux and Mac, you can do source var.sh. And if you're on Windows, remember, go on the command prompt and run the var.bat script. Next, you can follow we will follow the instructions inside this how to run section. Now I'm going to be referring to environment variables using the Mac format. So if you're on Windows, just go on the bottom of the README and you will see how to run the same lines, but on Windows. So the first step is to reset the environment with resim reset. This is to make sure that our last example that we compiled and played with is removed from the local simulator, so that we start from scratch. Next, we are going to be generating the account that we will act as with resim new account. Next, we have to build and publish our code by doing resim publish dot, which is the directory containing the code. So after it has built, it will publish it on the local simulator, and it will give the published package an address. Like the previous example, we are now going to be calling the instantiator function, which is instantiate machine, on this package by doing resim call function. And next, we have to provide the address of the package, and you can use the package variable to refer to the generated address. Next, the name of the blueprint. Remember, we named it gumball machine, so we write gumball machine. The name of the function, which is instantiate machine. And now we will provide a price, which is the first argument of the function. In our case, we will provide a price of 25. So when you run this command, you should see a success message along with the created resource definition of the gumball and the address of the component. So now we will try to buy a gumball. We do this by calling the buy gumball method with resim call method. and then the address of the component, which is stored inside the component variable. The next parameter is the name of the method by gumball. And now, remember that the by gumball method requires a bucket. So how do we send a bucket from our account? Well, the first account that you create with Resume New Account becomes your default account from which you are using funds from. So you only have to create a bucket, and then it will take the XRD from the default account. To send a bucket, you use the following syntax. You write the amount that you want to send, in our case 25, comma, and the address of the resource that we want to send. In our case, it's the Radix token. And we have a variable XRD for it so that you don't have to copy and paste this long address. So when you run this, you should see a debug message buying a gumball, and you should also see success message. Now to verify that it worked, let's do resume show, then the address of the account, which is stored inside this variable. And we can see we started with 1 million XRD inside the account, and we have 25 left, and we received a gumball, so this works. Now, let's try to, instead sending 25, let's try to send 10. As expected, it doesn't work. But notice that we didn't have to write a lot of checks inside our by gumball method. This is all done automatically by the Radix Engine when we are taking a portion of the bucket. And also, if for example, instead of sending 25 XRD, we will be we were sending another token, like another token, it wouldn't work also. And even if we didn't do any checks inside the method, because when we are trying to put inside the collected XRD vault, it sees that it isn't the type of resource that we specified at the beginning, so it fails. And it reverts all the states that was changed during the transaction. So now that's it for this example. We will directly go to the next one because it builds on top of the previous gumball machine. Before doing any questions. So the gumball machine that we created has a little problem. Like we store the collected XRD inside a vault, but it's stuck there forever because we didn't implement functionality to be able to retrieve XRD from it. And so we will be implementing that, a feature for the creator of the component to be able to withdraw the XRD that is collected inside it. And we will do this with the concept of badges. And I will go more into the details of what is badges. Someone earlier asked to get more information about that. So badges are, unlike other smart contract languages, where you are identifying your users with their address. On Radix, you are actually using badges, which is just a resource that acts as a badge that the user must present to access certain functions and methods, and also doing some actions on tokens like minting or burning. So this is more flexible because the developer doesn't have to implement the logic for the authentication, and it's the owner of the badge is able to simply send it to someone else if they want to change who has access to which method, instead of having to implement methods to change the array of addresses inside your smart contract, like on Ethereum. So we will go into the third example. So open up again, the lib.rs file inside the inside the third directory. For the state, it looks the same, almost the same as the previous example, except that we are now having a reference to the resource definition of the badge that is allowed to withdraw the tokens. And now, inside the instantiate machine function, you are creating a new resource with a single supply. And this represents the admin badge. And we only want to have one admin to be able to withdraw, so that's why we create only one resources. So the person owning this resource will be able to show it to the component to be able to have access to certain methods. So to create a badge is just like creating any resources. You call the resource builder, and you can create fungible or non-fungible badges, depending on if you want to identify separate users or with different metadata, or if you just want to refer to users in a fungible way, like in our case. The way we create the gumballs and instantiate the component is the same, but now, instead of only returning the component, we are also returning a bucket that will contain the admin badge. So essentially, the person calling this instantiate function will receive the admin badge. For the buy gumball method, it's the same as the previous one. But now we have an extra method, which is withdraw XRD. And what it does is simply take all from the collected XRD vault and return it to the transaction layer as a bucket. But notice the line just before the method declaration. This is how we make sure that only people presenting the admin badge is able to call this method. And the admin badge here is referring to the one that we are storing here, the resource definition that we are storing inside the state. So that's why we had to store it. So now let's try to run this example. Open up the terminal and go inside the gumball machine with authentication directory. And just like other examples, we are going to initialize some environment variables to refer to addresses by doing on Linux and Mac source with var.sh. And on Windows, the command prompt calling there's an error here. So it's var.bat that you are running. And just like the other examples, we are going to start from scratch. So we do resim reset. Next, we are going to create the default account from which we will send the XRD and from which we will have access to the admin badge. So we do this with resim new account. And now we have to publish our package to have access to its blueprint and functions with resim publish dot. After it's built, it returns the package address, just like the other examples. So we are going to instantiate the machine with resim call function, the package address, which is stored inside this variable, the name of the blueprint, gumball machine, and the name of the function, so instantiate machine. And again, we will provide a price of 25 to buy a gumball. So after running this command, you should get a success message. And now notice that we now have 3 new entities when calling this function. This is because now we are creating the admin badge and on top of the gumball token and the component that we are instantiating. So with the component address, we are able to buy a gumball. So we are doing the same step as the previous example, just to get some XRD inside it so that we can try the withdraw method. So resim call method, the address of the component, then the name of the method that we want to call, buy gumball, and we have to provide a bucket of 25 XRD. So we write 25, comma, and then the XRD address. So success message. So let's see inside the let's look inside the component to see if they receive the XRD. With resim show the address of the component. And you can see that it contains 25 XRD. So let's withdraw this 25 XRD. To do this, we will have to call the withdraw XRD method and provide the admin badge so that it knows that we have access to call it. We can look for the admin badge inside the account component, inside our account, by doing resim show and then the address of the account. And you will see that we have a gum token here, and we also have a gumball machine admin token. So this is the token that we received when calling the instantiator. So let's call the withdraw XRD method with resim call method, the address of the component again, the name of the method, withdraw XRD. And now notice that when we defined the withdraw XRD, we didn't provide any parameters that the user has to provide. But the line on top, meaning the authentication for this method, this actually adds a extra parameter that is that is your the badge that you have to provide. So that's why to send the badge, we have to do it the same way we are sending XRD. So in our case, instead of sending 25 XRD, we are sending 1 and the admin badge, which is the stored inside the admin badge variable, like this. So you should see a success message, and when we look into the component again, we should see that they don't have any XRD anymore because it's back into our account. And now, all the checks for the badge is done automatically with this line. So let's try to send 1 XRD instead of the badge resource. So to see what it does. So instead of sending 1 admin badge, we will send 1 XRD. And you see that you are not authorized to do it, as expected. So we are done with this example, and we are now going to go into questions. So again, you can access this platform by scanning the QR code or going to slido.com, and you can ask questions and vote for ones that you want to be answered.
was just thinking that we can, while you guys are thinking over some of the technical questions, playing with the code a little bit, keep the questions coming in. Definitely go, even if you don't have a question, just like vote on the questions that you think are interesting so we make sure we float things up here. I think probably after we take some questions, we'll also just kind of float around the room a little bit and check in with you guys, see if there's anything that, that you want to ask. Maybe while that's coming in, I might hit some of the lingering questions from before. Where do you see Radix in a successful scenario? Is it a network to replace all other smart contract chains, or will it communicate with other chains? Obviously we think Radix has got a good chance of being kind of the premier one. I don't think it's a one-chain world in the end. I think you're going to have kind of different. I think you're going to have different chains that have, different specialties and things like this. I mean, I think, and definitely bridges between chains are going to be a really important thing just in general. We're always seeing this. I think the primary thing is asset bridges. Like there needs to be ways of flowing value between these networks, and I think bridges, we're seeing a lot of that today, and that's going to continue. So I don't know, general answer to that one. Let's see, there was something.
So we have a lot of questions about the code. So is it possible to require that multiple badges are shown, like multi-sig withdrawal? At the moment, with the authentication model, what you can do is inside this this macro is to write different badges that you want. So maybe a second admin badge or anything else, and this means that to call this method, you either need to present the admin badge or the admin2 badge. At the moment, this is using this macro is only what's possible. If you want to do more complex scenario, you have to code it yourself inside the method. But we are changing the authentication model for the next version, so it will be more easier to write more complex authentication systems.
Yeah, in fact, even this stuff we can share. You can see this going on in the open source repo. We just don't quite have haven't released yet for you guys to play with, but it will allow. I had some of the questions people were talking to me about this in the break over lunch, about asking about how authorization work. We're definitely going to be moving to a model where there's two things you can't do today that you're going to do. One, we're going to have a more robust set of rules that you can use to apply to the auth for a given method. So you're going to be able to say things like, here's a list of badges, I need to see at least one of these. Or here's a list, I need to see all of these present. Or here's a list, I need to see 3 of the badges that are in this list. So definitely you'll have and we'll have ands and ors and stuff like this. You can basically build up these sets of Boolean statements that in the end, if you have a collection of badges that meets that requirement, great, you can access the method. So definitely things like multi-sig and if you're familiar with Gnosis Safe on Ethereum, you'll be able to build those things directly in auth rules on a method rather than having to write any logic around that. Really, really powerful. I wish we'd had that ready for today, but not quite. It's almost out. And the other thing I was going to mention about auth that you can't see in this one is that right now it's static. So right now you're saying, here is a particular badge that I need to see to get into this. The new version that's coming, you'll be able to basically refer to internal lists, for example, in the component. So you might have, here's my auth list, and you make that part of your component state. You've got a number of badge IDs in there. Your auth rule could just say, look, I need to see one of the badges from the auth list. But then your component logic could update that list. So for example, if you wanted to have something where you had, a set of employee badges that you'd issue and employees can access this thing, you'd be able to update who is and isn't an employee with time based on different badges. So it's going to get really flexible, really powerful.
Another question, is it possible to require, can you have multiple badges so several people can authorize the withdrawal? Yes, let's see an example. So here, when we are creating the admin badge, we decided to create only one because we only wanted one admin. If we want multiple, like 2, for example, we can just create an initial supply of 2. And notice that the 2 admin badge will be returned along when calling this function. So it's in the transaction layer that you will actually say, so you call this method, this function, you receive 2 badges, and then you decide to send one badge to this account and the other badge to the other account. And then both accounts will be able to call the withdraw method. Can vaults within a component be changed over time, even after instantiation of the component? For example, if you want to control which tokens that you are able to receive. It's not possible if you create a vault to change the resource that it can hold, but what you can do is instead have an array of vaults inside your component. And whenever you receive a new token that you don't already have a vault for, you just create another one and you insert it inside the array. This is a little bit like how the account component is working. So that's how it's able to hold multiple resources of different types. So to implement by multiple gumballs, do you have to call the same function multiple times, or can you just add a new param? You can add a new param if you want. In the by gumball, you could add for example, an amount. Let's say of type decimal. And here, instead of taking 1, we will take the amount that was asked. So if the user asks for 3 gumballs, we will take 3 from the gumballs vault. And another thing that is really nice with Scripto is that, again, you don't have to add a lot of checks. Like, you don't have to check that the gumballs actually have the right amount inside it before taking a certain amount. You just have to try to take it, and if there's not enough of this gumballs inside the vault, it will just fail and reverts everything that happened in the transaction. Can you have multiple badge? I insert this.
Cover that, yeah.
How can I know the addresses of all the components? Now, for this, that's a good time to see what we can do with resim. So if you do resim --help, you can see all the methods that you can call. So the call function, call method that we already seen. You can also export the ABI of a blueprint. You can mint resources. You can create badges, tokens. You can publish blueprints. But you can also show the ledger. So this will show you everything that's on the local ledger. So if you do resim show ledger, you can see all the packages that were published, all the components that was instantiated, and all the resources that was created. Now, if you want to have more information about a certain address, we use the resim show method command. So, for example, we'll take a random resource definition, copy it, and then if we do resim show and provide the address of this resource, we will see information about this resource. So, a symbol, a name, and also flags, and the authorities that are able to, for example, mint, burn, and everything that you can specify. Can component instantiator contains badges too? So now what we did is we sent a badge to the account, and then the account provided the badge when calling a method. But as we'll see later, you might have a component calling another component, and in that case, the first component would have to have the badge to have access to the second one. So you would store this badge inside a vault on the component. So it's not exactly the instantiator that contains the badge. It's more like the component contains a vault which contains the badge to use.
Yeah, I'm a little unclear about what that question is. You might be asking, can your instantiator create a badge that would be used to use with the instantiated component, which would actually be a pattern we'd come up with. So, for example, let's say you built a blueprint where you would expect that the component that instantiates is something where this requires some authorization. Like a user is going to come in and do something, and then as a result, a badge gets handed back to them. Definitely the pattern would be that the instantiator would create the resource manager for that badge type. It'd be like, all right, when this instantiates, we're gonna create that new type of resource to do the badge, and then and it might even hand back an initial badge or something like that. You could create the resource type, mint, and then hand something back in the instantiator. But it wouldn't contain the badges, but I'm not sure what was being asked there.
How can we get autocomplete for available methods and VS Code? Someone said that the basic Rust extension doesn't do this. So if the Rust extension that you installed doesn't show autocomplete when you are writing code, you might have to install the another Rust plugin, the Rust analyzer instead of the main Rust. Can you set expiration on badges? Not directly, but you could, for example, inside this method, you could do something like you could assert that the current epoch is less than or equal to, let's say, 100, so that you can only call this method if the current epoch is less or equal to 100. So this basically allows you to make a method not usable anymore.
Yeah, another way of doing it, it's an interesting question, is like, depending on what you're doing, there's a bunch of different ways you could expire a badge. Like, if you want to actually be able to like burn a badge that's being expired, the metaphor I'd use is it's sort of like having a ticket. Like you hand a ticket out to someone, you can hang on to the ticket, but at some point, you're going to hand it to someone and they're going to look at the expiration data and go, oh no, I'm sorry, this expired, and they take it away from you. You don't get it back again. Like I think that's another way of implementing it here, where you'd say rather than having it as only off, you could actually have the user have to pass the badge to your component. And at that point, if you made it an NFT, for example, you could put a piece of metadata on that ticket saying, this ticket was created at this epoch. And then when you accept it, you look at the current epoch, go, oh no, this is more than 50 epochs old. Sorry, I'm going to now take this and burn it and not give it back to you. Another way of doing it.
Yes, so this might be a reason why you decide to instead create a fungible badge. You will create a non-fungible badge. So like Matt said, if you want to put like a expiration date, you can just put it inside the metadata of the NFT. So how do you revoke a badge if, for example, you don't want your ex-wife to continue to have access to withdrawing from your account?
Sounds like a very personal question that someone's asking there.
So there are multiple ways that you could do this, just like adding an expiration date. What you could do is with the recallable flag, you could put the recallable flag on this badge, and when you don't want to, you want to remove it from someone else's account, you just you just take it back with by recalling it. Or I'm sure there are many other ways that you could do this. Could someone spoof a badge by creating a badge with the exact same name and metadata and bypass authentication? No, because even if two resources have the same metadata, they are not the same because their addresses, the address of the resource definition will be different. So this is how you differentiate tokens or resources, is by their address instead of their metadata. Maybe where can we follow the development of Xi'an and the sharded protocol? Can you answer that?
Yeah, so we're on a sequence of releases. So the stuff going on right now is development for Babylon. Once we get to the later stages of Babylon development, then Xi'an obviously is going to be primarily sort of a network update. So our network team would start transitioning over to implementing the Cerberus concept, like the fully sharded Cerberus concept for Xi'an. So I would say that development is not focused on Xi'an right now, so you can't really sort of follow along with it. It's one release at a time for us.
What's the difference between methods and functions? Functions doesn't have access to a state. This is something that you call on a blueprint, and blueprints doesn't have a state just like a component does. So functions is what you call on a blueprint, and methods is what you call on a component. And in the code, the difference is with the first argument. If you have the self argument, this means that you have access to the state by referencing to the self argument. For example, if you look at this function to instantiate the component, it doesn't have access to self, because that doesn't make sense, because the component is not created. What makes tokens different? Again, it's not the metadata. It's the address of the resource definition.
Also, as an add-on to that, if you create non-fungible resources, you've got two levels of uniqueness you get access to. There's the address for that supply of NFTs. So let me make it concrete. Let's say you're making NFTs for Pokemon cards, and you want to have all right, all Pokemon cards fall under this address. I've created an address that represents my set of Pokemon cards. But then within that, you can have individual cards. So you might have okay, you get your Pikachu and your Charizard, and then you might actually have individualized ones where it's like you keep track of the number of battles that Pokemon has been on an individual NFT, so they have the life of their own. So there's the address for the top level supply, but then there's also an address for each individual unit of a non-fungible supply, and that's also the way you would check those. So if you had some component logic that would say okay, only this particular Pikachu card can be used here, you would do a check on that non-fungible. I think it's an ID we call it. I'm trying to remember what the terminology was now.
Yes.
But yeah. So that again, that's guaranteed to be unique and cannot be faked.
Could users delete their badge accidentally? Well, if they send it to someone by accident, they won't have access to it anymore. Or there's a flag that you can put on resources. It's called freely burnable, and what it means is that anybody that has access to those tokens is able to burn them without having to provide authority. So this could be a way that they accidentally delete their badge, but this would mean that the badge would have been created with the freely burnable flag.
Yeah, it really depends on the use case. Like the issuer of that badge would decide, what is the nature of this badge? They might say, well, this is a raffle ticket. I'm going to hand these things out, and I don't really care what you do with them. If you want to burn your own raffle ticket, that's fine. That's up to you. So you could set freely burnable on it, and you could choose to delete that. And if someone made a mistake, okay, so it goes. But it might be that you have, I think a lot of badges are going to fit the category of okay, I'm handing this out, and I need to make sure that this is in a given place. I don't want to allow someone to accidentally delete this. It has to be handled, in which case you just simply wouldn't set freely burnable. In fact, you might even not set burnable if the component itself didn't want it to ever be able to burn it. So the issuer can sort of choose what nature of flammability they want on their badges.
Do you use call function only for the instantiation of the components? Not necessarily. The example that we saw, we created functions only to instantiate a component, but you could create functions for anything as long as it doesn't rely on states. So you could create another another function like ABC. And what it could do is simply do some debugging. And it doesn't, so you can call this function, it doesn't do anything, it's just show a message, but it doesn't instantiate a component. Or for a more concrete example, what you could also maybe want to do is just create a token and return it. So, like you see, we didn't create a component, and it's still valid. So you can create functions for anything. All the statements and blueprints are written as if they're synchronous. Is this the case, or is there some async magic under the hood? So all the methods and functions that you are calling are run in a synchronous manner, if I'm not mistaken.
Yeah, that's basically true. Or you could say that the state transitions that might be created by the logic are synchronous. Like, you're not going to have like race condition kind of stuff. Like, the transaction manifest has gone through step by step synchronously, and we don't have, there's no circumstance in which you could spin up like 2 threads in a transaction. You'd have blueprints that'd be fighting over the same piece of state, if that's the question that's being asked.
Someone is asking, IDE support for Scripto is the same as Rust? Basically, yes, but there's a bug in IntelliJ and like CLion, because we are using the code is inside a blueprint macro like this. It has trouble to give you code suggestions on those IDEs. So that's why we are using VS Code in our case. And this is not a problem from our side. It's really from the support of those types of macros on those IDEs. What is Cassandra?
Got a Radix fan. So Cassandra is a test network, you could say, that is part of what we call RDX Labs. So the primary team in RDX Works is focused on development of the products like Scripto and some other things. Then also we have RDX Labs, which is run by the founder of Radix, Dan Hughes. And so he's been working on the Cassandra network as a parallel research track on long-term thinking about where we might go with the Radix protocol. So recently Cassandra has been focused on exploring kind of a diverse set of methods of dealing with leader selection and synchronization of state between nodes, when you get to a sharded network. So basically he's providing this body of R&D that we can draw on when we're formulating the product roadmap.
Does a method call work as a transaction? So does it revert all operation before an error? The answer is yes. So just to give you an example, so if we are receiving a payment and I'll remove the amount here. So if, for example, in our Gumball machine, we put a portion of the payment bucket inside the collected XRD vault, and then here there's an error, the Radix Engine will revert everything that happened before that. Not only in this method, but also everything that happened before that in the same transactions. So that means that you won't lose your XRD, because at the end of the transaction, they won't be stored inside the collected XRD vault, because it would be reverted because of the error. So I think So I think that's it for the questions for the example.
Yeah, at this point, do you want to, I mean, maybe I could hit some of these, more general questions, and then, maybe, I don't know, do you want to go around and talk to the tables and see if there's any other questions that people are a little more shy about? So, yeah, let's do that. When are we planning on picking up the next session? 10 minutes? Okay, cool. Take a look at this. Is this going to be a double microphone problem for the sound person if I... Sounds okay. Okay, let me see if I can hit some of these. So how would royalties work per transaction? Wouldn't it make the transaction expensive? Well, I mean, the idea of royalties is it's a marketplace. So it isn't the idea that there's a fixed royalty that's assigned to something. The idea, and again, this is thinking out a little bit, but the concept we have in mind for this is that the developer gets to choose. They would say, for this blueprint, I would expect that a call to this blueprint has this much value associated with it, and they kind of need to make their own decisions about that was. So, it's the kind of thing like, in a way, it's sort of, I think of it like Spotify for developers. It's like on Spotify, every time you're listening to a song on Spotify, in the end, there's like a fraction of a penny that's being shaved off and being, accumulated to a bucket, and that gets paid out to the artist at some point. It's kind of like that. So, it's not as if you're going to have this accumulation of significant fees on your component usage. It would maybe be a matter of like, what do you think is the trade-off between making it too expensive that no one wants to use it and so cheap that you don't feel like you're getting adequately compensated? So basically I think market dynamics tend to take care of this for you. I think you'll find this equilibrium that makes sense for everybody. Can you explain the reason for the naming behind the milestones, Olympia Babylon? They seem pretty grand. Yeah, so this was actually a community thing going way back before we launched Olympia. We were in our lead up to the launch of the first network, and we actually opened this up to community input. We said, hey, we've got this series of 4 major milestones that's coming. There'll be more milestones beyond those 4, and we had a little competition where people proposed different naming schemes, and this is the one that came out. It was basically cities of the ancient world that bore wonders of the ancient world. So, well, yeah, I won't explain the ancient history, but we thought it was a good, and actually the community's done some really cool stuff as too. Every time we go through one of the releases, there's usually like some artwork and stuff that comes out about like the ancient city of Olympia, and it's like very representative of. It's like they end up coming up with something that's very symbolic of what we're releasing. Everything. It's very, very creative. I love it. Do you somehow integrate with Solidity? So the issue that I talked about with Scripto, somebody asked the question, is like, well, could you drop Scripto onto other networks? Basically, it cuts both ways on this. If we were to try to, let's say, implement the EVM on top of our consensus layer, we would have the same issues. We have essentially, particularly looking forward to the sharded network, our sharding scheme makes some really core assumptions about the way the application layer works. Basically, the application layer needs to formulate transactions and changes of state into a shardable form. So we use kind of a modified form of UTXO to represent state, but then we assign UTXOs in a very different way than Bitcoin or Cardano and any of the others. They're using something kind of similar, but it's basically, we've kind of co-designed these 2 layers to go together. So the issue is that in concept, you could implement something like the EVM and Solidity on top of the Radix network, but the problem is you would never get the scalability benefits of a long time that we think are a really core part of where we're going from a long-term point of view. And on top of that, to be honest, we kind of want to encourage people to come to Scripto. Solidity is fairly dominant today, but when we talk to Solidity developers, we don't hear a lot of excitement for it. It's, it would allow people to be able to pick up their code and drop it onto the Radix network, but honestly, we really want everything being universally expressed in this ASORD-oriented way on the Radix network, so there isn't this sort of conflict between, well, there's EVM style state and there's Radix Engine style state. We've taken a strong position on what we think, how we think things should be done on our network. Has braided sharding been demonstrated to work? So this is some of the stuff that's going on in Cassandra, for example. So like there have been a number of forms of the braided consensus mechanism. Actually, Dan's been playing around with variations on the consensus mechanism. So yeah, he's had functional Cassandra tests that have been using various forms of braided sharding, playing with different consensus mechanisms and leader selection and so forth around that. So definitely demonstrated to work. The other thing, if you want to get kind of into the academic side, is we worked with the University of California in Davis. They have a kind of a distributed network specialty research team there, and we've built a partnership with them as part of RDX Labs. Going back to the original Cerberus concept, they did a kind of a deep review of that consensus mechanism and the anticipated guarantees you could make around the braided network in the end. Is this something that should be able to achieve linear scalability? Does it achieve in consensus under certain assumptions of attack conditions? And the result of that was all really positive, and we've got that paper published on our website. Thinking very long term, how do you clean up the chain of unused code, assuming that that was not planned when the code was deployed? Any performance impacts? It's a pretty deep question. I'm not entirely sure what's behind it. I guess characteristically, in some ways, this is the nature of a distributed ledger, is that you're always going to have this historical state where you essentially need to maintain that historical state so that you can prove the current state. Even if you have currently unused code, you still need you need versions of that to be able to validate what happened in the past. Now, there are various techniques you can use to sort of collapse that down and reduce storage, and there's some culling you can do. In some ways, we have a better situation here than most smart contract networks because, for example, on Ethereum, every single token is a redeployment of an ERC type contract. So you have these. The network knows nothing about those things. It can't say, oh, those are basically all token contracts. I'm going to kind of, I'm going to store them in a similar way. All it knows is I've got all these independent contracts. Or in our case, one of the nice things about the blueprint structure is that every component that's instantiated from a blueprint is referring back to the same logic. Even though it's got its own state, you don't need to have parallel copies of the logic on the ledger because everything just points back to the same ledger. So this actually does save us quite a bit of storage in terms of deployments of stuff to the ledger. But I think when we get to the very long term of the Radix roadmap, I think we start getting into techniques to be able to cull historical state in a safe way. It's not really performance impacts so much as a matter of just a node runner burden. If you've got people that are running the network, the less state that they need to store means lower server costs for them and all that kind of stuff. An equivalent of an Etherscan. So we currently have an Explorer. If you go to explorer.radixdlt.com, you can find that. It's very simple for the Olympian network, but performs the same basic function. And yeah, definitely there'll be something around that in the Babylon network as well. That'll be expanded to have more functionality. Do badges mark the end of the private key, public key paradigm? Ooh, bold statement. Not as such. Private key, public keys are still very important. I think it changes the nature of how they get used. I think, I feel like this is a softball question. This is the kind of thing that, this is something I would like to talk about. So what I do think it marks the end of is the notion that there is a one-to-one correspondence between a human being and a private key and an account on the ledger. That is a really problematic chain because it loads a lot of risk into it and it loads a lot of complexity into the system for the user. This is what's holding a lot of people back from using DeFi today, is the fact that you have this notion that all of the stuff on the ledger in the end is controlled by this private key, and there are different ways of getting to that private key with seed phrases and ledger devices and all these kinds of things. But in the end, if you lose access to that, you lose all your money. And if someone else gets access to it, they get all your money. And that's a real problem. That system is never going to be suitable, and it doesn't match general expectations we have for robust security mechanisms where you have recovery factors and you have multi-factor logins and all this kind of stuff. That's the world of practical security that we should live in, and I think that needs to carry into the DLT world. And so that's very, very much a part of why there's multiple reasons, but one of, I guess, the nice benefits of the nature of our accounts that our accounts are based on instantiated components and authorization to its methods. This allows us to break that one-to-one correspondence. We can do multi-sig structures of various kinds to provide really much more mature models of guaranteeing ownership. However, you're still going to have private public keys in there. It's just that we get to use them differently. Like, for example, you could have a private key that the user doesn't have to write down. It could just be something that's generated internally and used if you're not fully relying that on the security. If it's one factor out of many, then it changes the nature of the security design, the security model. So. As with any programming language, we're getting sorted around here. Looks like Radix v1 is written in Java. Is there a plan to migrate the engine or future versions of the engine to Rust? Probably. I can't guarantee that right now, but I think at this point we are almost certain that that we are going to be implementing the public network version of Radix Engine v2 and that stuff in Rust, because one, we really decided that we like Rust quite a lot, and also it's just kind of nice that if you have deployed code based on Rust, having it run through a Rust stack makes a lot of sense. As with any programming language, Scripto's primitives make it more adequate to some use cases and less for others. Do you have any examples of those? You're asking me to criticize our thing. I'm going to cheat a little bit. I'm going to say that Scripto's primitives themselves are, again, really designed for finance and ownership and assets and all this kind of stuff. But you're not limited to those primitives. I mean, it is an extension to the Rust syntax. So you have, there are a few things that we've pulled out of general Rust because they're kind of not appropriate to public ledgers, but basically speaking, you have access to the full power of Rust, and it's hard to argue that you can't build whatever you like in Rust. It's a very, very powerful, flexible, expressive language. So you still have that. I think what we find is if you're building finance stuff, you have this really elegant set of primitives to be able to get to things really quickly and securely. But if you have a use case where you're saying, well, okay, I have that, but actually I need to write some like fairly complex general logic that wraps around all that, you have access to all that. So I think in the end, it's actually less about the Scripto primitives and more about just what are public ledgers useful for. And again, my belief is that public ledger, we're not going to run everything on a public ledger because there are definitely some trade-offs associated with it. But for this whole world of keeping track of ownership and identity and all those sorts of things, it makes a lot of sense. And you can do basically whatever you want. Follow-up to the sync question, how would it work calling an external async function? You can't. So this is also one of the sort of natures of a public network. So Scripto logic, components that are on the Radix network, are only aware of state on that network. So this is one of the reasons why you need things like oracles. Like if you have a component that needs to be able to read, I need to know what the external temperature is in Lisbon on a certain day to execute some logic. I need to have something off the network which is pushing that information into the ledger rather, where component logic can reach it. There's no way of directly calling out to the outside world because the rest of the world doesn't operate on the same consensus rules as the internal network. So there needs to be some sort of off-ledger bridge that is constructed that can make things available on the network. Hopefully that answers your question. Keys are not accounts, and accounts are not keys. Exactly right. That's exactly right. Keys, this is getting ahead of ourselves, but I'm not giving anything super secret. I had this conversation with somebody over lunch. Where we're going is that signatures on a transaction, you're still going to have to sign transactions like you do today, but you can provide multiple signatures. This gets into multi-sig. Those signatures are going to ultimately be translated automatically into badges. And what this allows us to do is we control all of our auth through badges and rules around multiple badges that need to be presented in order to get access to things. So I'm not going to go deeper on that because this gets into like how we're doing this, but basically that's where it's going, is that keys basically and signatures that are done with keys ultimately just get translated deterministically into badges, and it all fits into the same auth model. Why the need of a bucket? Can you not just move tokens directly between vaults? Yeah, it's as if you were in the room about a year or two ago when we were discussing this stuff. Yeah, we went through that trade-off of sort of like, why couldn't you just sort of say, okay, I want to take 5 tokens out of this vault and then do something with it? The problem is, ultimately, you need some kind of container. Like if you have resources, if you say, okay, I want to pull fiber. Remember, these things behave physically. This isn't just updating a number. You're telling the Radix engine, I wish to pull 5 tokens out of this vault. The question then is, what do you have now after you've done that? How do you refer to it? And it became very cumbersome to say, like, you basically need some kind of wrapper that you can manipulate, that you can have functions to access to. So the most convenient thing was like, all right, we just have this bucket. As soon as you pull something out, it immediately gets introduced into a bucket. Like basically the bucket gets created implicitly. If you do a take from a vault, what you get is a bucket back. And that bucket then allows you to do certain things. In Rust syntax, you basically have access to certain methods on that bucket. You can take that bucket, you can take other stuff out of it, you can get the count of currently what's in that bucket, you can put it someplace else. It just becomes this very useful object you use to move stuff around. Also in the transaction, you have kind of the same thing. Again, I had this conversation with somebody over lunch. One thing we didn't talk about was that in transactions, when you have these multiple lines of commands, the return from a component, if it returns a bucket to you, that bucket has to go somewhere. We didn't really explicitly say it, but where it goes is it goes to something we call the work top. And the work top is basically a place where a bucket can live for the duration of a transaction. And at the end of the transaction, it needs to be clear. So again, you need to have these just ways of referring to things. I call into a component, I get a bucket back, and then I can take that bucket from the work top and I can pour it into the next component and go from there. It's just a convenient way of referring to things. That's it. And that's probably time to. Cool. 10-minute break? Okay, let's take a 10-minute break.
and dubious honor of interrupting your workshop on how amazing Scripto is to talk slightly before the end, because I actually then have to jump on a flight and fly out. So slightly different order. After this, you will get a final presentation from Clement to talk about the wonders of Scripto again. But what I wanted to do is give you guys a bit of an overview about what we're trying to do with Radix and the technology we're creating. So why are we building? One of the things that I think all of the people who helped create the Radix technology, all of the people who have been part of the Radix journey believe is that finance is letting us down in 1,000 different ways. And a lot of those are small. Like, it just sucks a bit to send money internationally. It just sucks a bit to buy stocks and shares. It just sucks a bit to not have access to different financial products depending on where you are in the world. It just sucks a bit that you have to pay brokerage fees. It just sucks a bit that it takes a month to get one payment into a pension scheme. Like, all of these things collectively create an experience in our lives that we're not used to, which is things that just don't feel very user-friendly. Like everything else with the web and with the modern tech stacks have got better, but finance sort of just hasn't. So our vision, what we're building towards, what we're hoping to achieve, is a radically better financial system. And we think that that's something that is achievable, but it's only been achievable with this new technology that's come along, like blockchain infrastructure and the ability to think global first, rather than what we have at the moment, which is these badly interconnected archipelagos of little islands where each little company, like the London Stock Exchange or the New York Stock Exchange, has decided its own way of implementing and made something that's fundamentally incompatible with everything else. So what's that going to look like? We believe, the reason we build and we believe what we're building towards is that decentralized finance is going to eat traditional finance. And the reason we believe that is because it's just a fundamentally better way of making finance work together. So if you think of what the internet is, and Matt covered this in his presentation, but DeFi is finance built for the internet age. It's suddenly this way of being able to say, well, if I built a financial product and you've built a financial product and I've got a customer base and you've got a customer base, suddenly those are shared. If you've got some assets over here, they can move instantaneously to something over there. And you don't have to have permission to build in this infrastructure. Previously, if you wanted to build against a financial product, if you wanted to build against PayPal or Stripe or any of these things, you have to go through this process of onboarding. Whereas in this world, you can do everything. There is the possibility inside this technology to do everything that traditional finance does today, but faster, cheaper, and more efficiently. However, there's still a long way to go, right? We're in the very early phases of this, and I'll show you quite how early we are. But when it happens, and it will, we do think and hope that billions of people will be better off. Because it's not just like, people often talk about like banking the unbanked, but a lot of this I think is wider than that. It's about providing people the tools to be able to have what they need for their savings, for their investments, for their future selves. And at the moment, those things are all incredibly hard to access. Like, even if you live in a Western world and you have the ability to sort of like get a stocks and shares account, they are not accessible. They're not accessible things, and most people don't invest like that. So it's not just about giving access to everyone, but it's about lowering the barrier to entry and creating better products that makes it possible for people to have better financial experiences. Cool. So how are we going to make sure that happens? Again, this is something that Matt will have said. So like our mission, the thing that RDX states that we're doing, is to give builders everything they need to obsolete traditional finance. This is how we see it possible to actually make our vision possible. But like what that actually really means is our mission is to empower you. Like, we're not going to build all of these future financial products. That's not our job. Our job is to create the infrastructure that makes it possible to be a leaping off point for the success of others. And it really comes down to what the community can imagine, what you guys can imagine is possible now you're given this new set of tools. Like, what could you actually build? And so what we are always trying to do is go, how can we keep that barrier to entry as low as possible? How can we keep making it possible for people with a great idea to go on and build something amazing? Now, quite how early we are. Like right now, DeFi is 200 billion or 0.2 trillion. That's a dot you can't actually see. DeFi 100x from now is 20 trillion, but the global financial system as it is now is 400 trillion. But that's only with about 13 to 20% of the total assets of the world actually represented in it properly. Like, what happens when the metaverse comes along on Web3? What happens when you actually open up finance to the point where, you know, large parts of the African subcontinent can get involved in finance? That's going to be a much bigger number again, but all of that has to be opened up by new technology. So what's happening right now is this really interesting thing. Like, we see these public ledgers as like a two-sided marketplace, right? On one side, you have capital. On the other side, you have dApps. And capital has found ways to flow into this space incredibly quickly. It's 220x'd in 24 months. So it's gone from $1 billion under management, DeFi, 24 months ago, to $220 billion today. It's 220x in 2 years. Developers have 2x'd. That's 19,000 full-time Web3 developers today. And that's not because a lot of people haven't tried it. Lots of people have tried it. A lot of people, about 500,000 people, have tried programming with Solidity. But only 19,000 people are building. And that's actually not because there aren't jobs. Like, there are jobs. There are very high salaries available. It's because of how insanely hard it is to actually build production-grade DeFi today. And right now, one developer, if you divide 220 billion by 19,000, one developer is worth about $11.5 million in total value locked, meaning that there is about $11.5 million of capital looking for the next opportunity per developer in the space. So not only is it incredibly early, there is also a deficit of talent in the space. And we hope, we believe, what we've built means that that problem with talent being able to access, being able to build amazing things, has been radically reduced as a barrier with Scripto. So why should you build, and what should you build? These are interesting questions. The first, I'd like to tell a story about Hayden Adams. Actually, show of hands, how many people know who Hayden Adams is? That's really interesting. 2 people. How many people know what Uniswap is? Hands up. Okay. So Hayden Adams is the founder of Uniswap. So in July 6th, 2017, Hayden Adams was laid off from his job in Siemens as a mechanical engineer. He was not a programmer, had never programmed before in his life. But at that point, one of his friends said, hey, you should try to learn Solidity. This is a great opportunity for you. You should try to learn Solidity. So from July to October 2017, he didn't go into the Ethereum community going, I'm going to build Uniswap. He just went, I'm going to try this out. I'm going to see what this is all about. I'm going to play around with the tools, and I'm going to teach myself how to become competent enough to build something. And he spent a lot of time in the community. He hung out on the forums, he went to meetups, he went to the developer events, he met some great people, he got some great feedback. And in October to November, so a 2-month period, he wrote Uniswap v0, which was the proof of concept. Now, didn't actually do anything apart from allowed you to swap from Ethereum to the Uniswap token and back, and it really wasn't actually launched. It was just showing what was possible. And this is what it looked like, which, you know, he knew was janky and weird, but it did the job of proving to him that he could actually get to the point of building an application. And my God, is Uniswap a simple application at base. In terms of the number of lines of code, it's very, very, very simple. Now, November 2017 to November 2018, 1 year, he went to Uniswap v1, production ready. And this is actually the side note of exactly why Scripto is important. Like, someone was able to get to a proof of concept in 2 months and then spend the next 1 year smashing his head against a wall, trying to work out how to make this code work, how to make it secure, how to make sure that it didn't get hacked, and he ended up refactoring it 5 or 6 times during this period before he actually got to Uniswap v1. And this is the problem. Like Solidity, you can get to a concept easily, but getting to production code is incredibly difficult. November 2018, he launched. $34,000 came into it. 1 year later, it was at $20 million, total value locked, 588 times more. Another year later, it was $3 billion, 150 times more. And then the year after that, $10 billion, another 3x. So what are the lessons I take away from this? There's 3. First is, a person with no coding experience can build something incredible. We are this early in this industry at this time that everything is greenfield. Everything is just an opportunity, and actually the things that's strongest right now are the ideas, rather than the, building something of an incredibly complex user interface, incredibly complex user experience. Actually, capital in the space and users in the space are incredibly forgiving versus almost any other area where we have become used to as consumers polished user experiences that if they don't instantaneously gratify us, we just leave to the next application because it's there. In crypto, because the opportunity is so large and because the number of people actually building great things is so small, a small amount of code and a big idea goes an incredibly long way. The second thing is getting started by learning is the first step. Like, Hayden didn't know what he was going to do when he first got started. All he did is he was like, there's a cool community here, I'm going to go hang out, and I'm going to learn how to use these tools. It wasn't, I'm going to build Uniswap, I know what the next billion-dollar idea is. It was that learning by doing was the way in which he saw what was the opportunity could be. And the third thing is something to sort of think about is the founder of the first $10 billion app on Radix might be in this room. Like, this is how early all of those opportunities are. And that's not me saying, hey, this is a competition, who's going to be first? It's me saying there is so much opportunity here in terms of the headroom that's available for decentralized finance to eat traditional finance, for us to reinvent what's possible with financial applications, that every single person in here could build a $10 billion application and you still wouldn't be taking business from each other. So, to end with a cliche, the journey of 1,000 miles starts with the first step. Really is just what you are doing now is you've taken the first hard step of learning the tools, getting started, showing up, and starting to play with this stuff. But like a lot of people feel like there's a big abstraction between what you do today, what I do today with like a simple code application like a gumball machine, and building something that can actually control $10 billion of total value locked, but it's actually not that far. So I just want to say thank you so much for coming, and I hope that today inspires you to take the first step on your journey. Thank you. So I'm happy to do some Q&A if you want to do that. You want to bring up the thing? Okay. Yeah? Anyone have a question?
If you had to start again today,
Yeah.
the CEO of Radix,
Yeah.
what would you want to work on? Like, what would you be like red hot to go and implement on Radix?
Yeah, that's a really interesting question. So, like, if I was to start again today, not as the CEO of RDX Works, what would I build? So the thing that I find really interesting about decentralized finance is the way that it's reinvented a bunch of really basic ideas. So in traditional finance, you have this idea of discrete products. So like a customer comes to me and I write them a loan. And that's a one-to-one relationship. So like a mortgage is a great example. Someone comes to me and they want to borrow against their house, and it's a one-to-one relationship. What the idea of pools and shares, liquidity pools like Uniswap started with, was this idea of many-to-many financial interactions where you go, okay, I'm going to put my assets in with a bunch of other people, and we all share together in the results of the success of whatever that product that's being created on the other side. That was really powerful for a few reasons. One is that anyone could come along. I've already got these assets. I've got some USDC and I've got some Ethereum, and I'm not really doing anything with them. So I can just put them in Uniswap and I can start earning fees. And on the other, and I share collectively in the fees that are made by that application. On the other side of it, anyone can come and trade against that. It's not discreetly trading with me, it's trading with a pool of people. What that's done since then is started to create these ideas of like group liquidity Schelling points. So like the market collectively comes up to a risk price for something, and you can see that in Aave with how much it costs to borrow or how much it costs to lend against the Aave product, where people are like, yeah, sure, for 8% per annum, I'll put USDC in, but like for 5% per annum, I'm not interested. But the price automatically moves, so it's like the collective intelligence of the market. One of the biggest areas of finance in the world today is our derivatives. It's about $4 quadrillion. It's about $2 quadrillion that are cleared via DTCC, which no one's ever heard of in America. But it's that's the nominal value of derivatives there. But essentially, a derivative is a very simple product, but it's taking a risk-based view on what the risk of something happening in the future is. So let's say that there's Apple shares at $200 today, and someone wants to take a view of that they're going to go up from here, and someone else wants to take a view that they're going to go down from here. That whole aspect of pricing is currently done entirely discreetly in the current financial industry. So like you want to buy some, if you want to buy some option or derivative, then I as an investment bank will write against my book what I think I want to charge you right now. To me, that seems insane, and it's actually proven to to create a large amount of inefficiencies in the market. But there is just more value in that than anything else. So I think, Jacob, to answer your question, if I was not doing this today, I would be looking at derivatives. But it's a relatively complicated market area, but I think it's really exciting.
Scripto?
So no, because Scripto's still sandbox environment. So Babylon is when we integrate Scripto into the main net, which will be Q1 next year. And the reason there's several reasons that we took this approach, but one of them was like I was in the early Ethereum community, in the early meetup community in Ethereum, and people started building really early with Solidity, but Solidity didn't really know what its application area was. There's a bunch of problems that happened early in how Solidity worked on Ledger that caused a load of problems with the EVM as well. But then Vitalik also was like, oh, man, I just wish we hadn't put Solidity straight into Ethereum. Wish that we'd waited another 3 to 6 months to sort of get some extra features and change some ways it works. Because the problem with a public ledger, it's a lot like shipping hardware. Like, it's really hard to patch in place, and you also have to treat all previous state in a way that you can't just go, oh, that state's no longer valid. So like you have to deal with all this legacy information that you can't just do what you do in an enterprise stack and copy it all over or something like that, or it's a lot harder. So we decided, like much to the I think sometimes crypto can be too short-termism. Like it can be, there's too much pressure to just get something out as long as it works, just get something out, where we're taking the view, look, if this is going to be the infrastructure that runs $400 trillion, if we even have an ambition of doing that, we have to think about what needs to be true about the programming language, the execution environment, for people to be able to trust that infrastructure in the long term. And that really does mean testing things out, right? Spending some time, getting feedback, making sure that it works. Like, it's a combination of product market fit and testing. Like, does the programming language actually work for people? Do people love it? And at the end of this, we want your feedback, especially if you don't like something about it, because we can change it now. So if you've been doing Scripto and you're like, this is all awesome, but this thing just doesn't work quite for me, we want to hear that. We don't want to just hear positive stuff. We also want to hear where you think where you're struggling, where things are not working for you, because that helps make sure that we get that programming language perfect when it ships on Babylon, but also at the same time it allows us to spend a lot more time testing the execution environment, all that kind of stuff before it goes live. So, no. That's a long answer to a short question. No, there aren't any today.
Hi. Is this working? Yep. How do you think about stable coins, and do you have any thoughts around integrating stablecoin technology with Radix or with Scripto?
Yeah, do I have thoughts about stablecoins? Yes, yes, very much so. So, like, the first thing that got me interested about Radix was stablecoins. My view of money, just in general, is that money isn't a global phenomenon. Money is a local phenomenon. Right? We think in the local currencies of the places that we live and we work. We want to invest in the local currencies of the places that we live and work, because money, for most people, is a shortcut. It's an intellectual shortcut. How do I know what the value of something is? Well, it's because I can compare it to everything, to what my brain thinks in. Oh, I think in dollars. Oh, that's $10. Oh, that's cheap or expensive. Or like, this is this much and that is that much. All of those things are all ways of us getting to a short answer of whether or not something is good value or bad value, or how we want to allocate, how we want to spend. So for me, stablecoins are the key to adoption of these public ledgers. Like, while Bitcoin's an interesting idea for like a inflation secure store of value, or some like sort of idea of like an apocalypse resistant store of value, it doesn't help people every day to understand how they want to spend or invest. So for like stable coins, I think are going to be, and are already shaping up to be, one of the next big battlegrounds, right? Like, so if you look at what is happening with Terra at the moment and how they're expanding very aggressively with UST, if you look at NEAR coming in and saying, hey, we're going to do an algorithmic stablecoin, if you look at the success of USDC and USDT, two huge, centralized fiat-backed stablecoins, and their importance in the DeFi space. Because essentially, if you're going to build a financial product, most people don't want to take two bets. They want to take a bet on the financial product and a bet on the settlement instrument, right? Whether or not what I get is actually going to be the value I expect at the end of it. They want to take one bet, the thing that they want to bet on, the future price of Apple. And at the end of it, I'll get dollars back. Or at the end of it, I'll get pounds back. So stablecoins are essential, but they're early. Like, I say that in terms of, if you look at like the cycle of the technology, like what people were playing around in layer one, like 2013, 2014, how they were thinking about things in a very primitive way, and how you do scripting and how you do consensus and how you do scalability. We're at that sort of stage with stablecoins right now. So I think there's probably a few years to go before good, really reliable ways of creating many representations of currency on ledger without segmenting liquidity. This is the key, right? Is right now you have a segmentation of liquidity between USDC, USDT, DAI, which is somewhat helped by things like Curve. But when you start getting more currencies, you get even more fracturing of liquidity. So there's a bunch of stuff to come there, and it's something, you know, I personally have taken interest in, like, ever since I got into Radix about 2017. And if you look in the early history of Radix, we even proposed the Radix token being a stablecoin rather than a non-stablecoin, but we decided that that was one level of complexity that was unnecessary in the system, so we removed it. But yeah, stablecoins are going to be huge. I think anyone who's thinking about building them, now is a great time to be experimenting, because there definitely isn't a winner of that system yet, and there's some great thinking out there. So yeah, stablecoins are awesome. Does that answer your question? Yeah. So the question was, is there anything you can do with the Radix code or Scripto that will facilitate stablecoin development? So the simple answer to that is absolutely. I think the main thing is, I always talk about, like, so Steve Jobs has this wonderful expression where he talks about the point of computing is like a bicycle for the mind, because he goes, you know, if you look at all of the animals' efficiency of energy use to travel, right? You know, the top of there is the albatross, its ability to soar for days on end without expending much energy. And then you look at the human, and it's sort of like well down there, it's like in 30, 40s. But then you put a human on a bicycle, it suddenly becomes the most efficient animal on Earth to be able to travel. And so this idea of the computer being a bicycle for the mind, I think, is a really important idea when you think about the design of any tool that helps you do something productive. So Scripto's whole point is, how do you get out of the way of the flow of inspiration? Like, how can you prevent the tool from stopping you in your state of flow? And what that ends up meaning is that complexity is easier to build quickly, right? And I do think that whatever emerges as a stablecoin system is likely to be pretty complex, because the global financial system, the FX market, the way in which money markets work, all of the ways in which flows of funds work to create a liquid global financial system around currency pairs is really complicated. And I think very few people fully appreciate how nuanced and complicated it is. But the better the tool is at being able to express complexity in a predictable way, the easier I think people are going to be able to build these things. So I can't say what shape it's going to be. I can just say that I believe that Scripto will make it easier to build things that get closer to modeling what is actually necessary to build them.
Cool, thank you.
Perhaps there is a special step you have to do to introduce your business, is to explain what is different from what we hear about crypto monies, DFT, and what NFT, and what it could be used. And my second question should be, could you tell stories like you were telling now from Uniswap, of applications that were done with Scripto by Radix?
Yeah, so those stories are yet to come, right? Like, we are still. So your first question was like, what makes Radix different from everyone else? Yeah, so that's a long answer. The short version of that is that we think of these public ledgers as a full stack, right? Because you have the user, the everyday person who wants to be able to access decentralized finance. They need to be able to interact with it in a way that feels safe and intuitive. You then have the application developer. They need a way of being able to build on these platforms in a way that doesn't bottleneck their success, either because they can't get developer talent or because the platform doesn't scale enough. You then, underneath that, have consensus and infrastructure. How do you make sure that that layer that you are wanting global finance to live on top of is as resilient as possible, because if you're going to be building a network of the scale of the internet, resiliency is something that intrinsically has to be a component of it. So we think of the full stack for DeFi, and every single layer of our stack has been built to interact as seamlessly as possible with the next, and no one else in the space has done that. No one else has gone from user all the way down to infrastructure and thought about each layer and each customer type and each audience and what is necessary for that infrastructure to do. So most people in DeFi, and this goes back to the short-termism versus long-termism, most people in DeFi today, layers like Avalanche or layers like Near, or even like Solana, have gone, well, let's see how we can copy what already exists. But the problem is that everything that has been copied in terms of the EVM or Solidity is a prototype of what we think is a prototype of what actually is necessary. So MetaMask experience sucks, but it's the industry de facto. The programming environment of Solidity sucks, but it's the industry de facto. EVM, the efficiency of actually execution of the EVM, means that something, you have, good example would be Solana. 65,000 transactions per second is what they can do. But then if you translate that into Uniswap swaps per second, it's only 197. And 65,000 is the most that this infrastructure can do, but when you look at it as an application area application, if you look at what is actually performing, it's barely better than what we have already, and it's certainly not going to be enough for what we think is going to be potential for how many activities, how many decentralized finance applications are going to be happening on top of these ledgers. So what makes Radix different is our approach to going, what is sufficient for the end state rather than what just gets us a little bit better than today. But each layer has a very well thought out engineering approach that has a lot of documentation and thought process behind it, which I would definitely encourage you to dive into more deeply. In terms of stories, that's what these events are the start of, right? We only launched Scripto, the programming language, the ability for anyone to even express themselves in this new way, in December of last year. And 4 months in, we're already seeing some amazing stuff coming out of our community, but it's early stuff. It's going, well, if you wanted to re-implement Uniswap in Scripto, what would that look like? And what more could you do than you couldn't do today? But it doesn't have any money in it because it's not live on a ledger. It's much more about what is the community of people that will be built around to grow, to make sure that when those applications start going live, there is a group of people who feel passionately about building in this stuff, because if you're an entrepreneur or you're someone who's thinking about building a project, what matters to you isn't just whether or not that project will work, but whether you can get the team and the support that's necessary to keep growing that into something significant. So right now, that's what we're focusing on. Sure.
Another problem is the general problem from the blockchain, because you have to save all the previous transactions. The amount of data that will fill the computer will be very high at a certain time.
Yep.
At the banks, they save the data during 5 years, during 10 years, then they save the sold, and they delete all the old data.
Yep.
Do you have a politic into this field? And also, does the regulator give you mandatory rules or things to apply in this field?
Yeah, it's a really interesting question. So the first question was if you're running huge amounts of financial applications and transactions on top of a ledger like this, are you not going to end up creating very large amounts of data? And then how does the ledger deal with that very large amounts of data? And then the follow-up to that was, how does this intersect with regulatory requirements? An example with GDPR and right to be forgotten and stuff like that. So I'm going to answer the second question first. The second question, it's really not clear at the moment with the regulation. You can't prove that something's deleted once it's created in a system, especially in a decentralized system. So the overlap between GDPR and the right to be forgotten on top of these public ledgers is an area that's yet to sort of be played out. I don't know how that's going to go yet. In answer to the first question, that is actually one of the first problems that we were looking to solve when we built Cerberus. So Cerberus is our consensus mechanism, and we started with a massively sharded infrastructure of 2 to the power 256, which is what Matt mentioned earlier. 2 to the power 256 shards is roughly equivalent to like 10% of the total atoms in the universe. It is a number that you can't really get your head around, or I can't get my head around at least. You guys might be better at maths than me. So the reason that you start off with this massively sharded infrastructure is because the scale of data that you're going to have to deal with is going to be so mind-bendingly huge. You can't have one computer or a set of small number of computers who deal with it. Like you have to be able to think at sort of Google scale. So if you look at Google and all of the data that it holds, even if you dropped the entire data set that Google has, including their copy of the internet. I found out this recently, but they literally have a copy of the internet, which when they need to test particularly large updates, they test the update of like Chrome and things like that against their copy of the internet before they roll it onto the real internet, which I was like, that's cool. You would still end up with like less than a few bytes per shard. So that gives you the idea of how much data this shard space can deal with. So, and your question's a really important one, because if you look at something like Solana, if it actually did 65,000 transactions per second, that's something like a few terabytes of data every day. And so if you're making a few terabytes of data every day over a period of time, you're going to start to have a real problem, but Solana doesn't shard. That's a real problem. So the starting point of having a massively sharded data architecture and then building a consensus algorithm that's able to deal with cross-shard consensus to be able to allow parallelism, but at the same time synchronicity, that was the core realization of being how you could actually create an infrastructure that could deal with the data. So the infrastructure can deal with the data and can keep storing it for as long as we're going to be able to produce data on it. Whether or not it ever gets pruned, and under what circumstances it gets pruned, that's still to be cleared in terms of how the applications need to use it, what the stakeholders of the system want, and what regulation requires. And I like, my answer to that is we're not pre-guessing where that's going to go. We're just going to see how the industry matures and build engineering solutions as we go. But yeah. Hey.
Using the finalized contract transaction as a KPI, as you just mentioned on Solana, how much should we expect a drop when we look at that KPI coming Babylon? So from transactions per second to finalized contract interactions per second.
That's a question that I am not going to answer at this stage. I think that's a question for Matt if he. So the question is like if Solana if Solana is 65,000 transactions per second but only 197 Uniswap swaps per second, what would be the equivalent drop on Babylon if we say Babylon can do 100 transactions per second? What is the drop that you would expect in terms of a Uniswap swap per second?
Hello. All right, there you go. Fortunately, it's a pretty easy answer. So one of the benefits of the way we've architected the system is that essentially each transaction is equivalent. Like you can kind of see like the way you formalized it here. Like if you have a simple transfer of tokens from one person to the other, it's like, okay, I'm pulling some tokens out of one place, putting it in a bucket, giving there, depositing it. From the ledger's point of view, that's a DeFi transaction, just like anything else. It's not characteristically different than a Uniswap transaction. So for us, the cool thing is if I say, okay, we've 50 TPS, I mean, for anything, there isn't really this drop-off because we haven't split these two layers. We haven't said, well, there's one world that's like, okay, this is just token transactions, and we can simplify that down, and there's this other world that's just smart contract interactions, and that should carry forward. It'll be a little different with Xi'an because when it shards, now you get into the complexity of a complexity is there's a bunch of things in it, but the amount of state the transaction touches will sort of define the amount of shard space that you need to perform consensus on. So in Xi'an, things will change a little bit because a transaction that's touching many different components at once will require more consensus behind that, which would change how fees get paid and some other things like that. But nonetheless, the idea here is that your per shard, per application, if you will, throughput should essentially be more or less constant. Everything is equivalent.
So short answer is we expect it to be much closer to each other, but we're not quite sure how much. But yeah, like you shouldn't see like a 99% drop off for sure. Last question.
Hi, Piers.
Hey.
I was wondering on the stablecoin side how you feel about CBDCs and whether or not they're going to compete with DeFi, or what's the direction you see that going?
Yeah.
And also following on that, sorry.
No.
There's a kind of an uncertain looming regulatory landscape that we're heading into.
Yeah.
Are you kind of pushing towards building this platform, this open platform that anyone can develop on, and getting to that stage where you can't be the single point of failure anymore? And I suppose this goes for any crypto team, not just Radix. So that's my two-part question.
Cool. So CBDCs, central bank digital currencies. So what I'm seeing, like heuristically what I'm seeing at the moment is the crypto space does something and on a cycle, and the cycles are about 4 years. Crypto space does something, then a cycle later, so 4 years later, the enterprise space does the same thing. And then 4 years later, the government space does the same thing. So 8 years ago, the thing that was really hot in crypto was private networks, private ledgers in the enterprise space, right? So R3 and Corda and Hyperledger and all of these kind of things. Because what people went is, blockchain technology, that's cool. Let's forget about the crypto permissionless decentralization part of it, and let's just take this blockchain technology and let's apply that in finance. And if we're a big bank, we can get together a bunch of big banks and we can all decide that we're going to work together. The reason that fails, in my mind at least, is because if you have a closed permission system versus an open permissionless system, the activation energy required to both get new partners and let people use it is much higher, right? So even if you are the most powerful banking network in the world, you still have competitors, right? Great example of this is R3. I think it was Goldman Sachs or JP Morgan didn't join, and they create their own competing consortium. What that's done is made it net less likely that either of them are going to succeed. And in the early days of the internet, France did a similar thing. When the internet came out, France went, oh, that's cool. We'll make our own version of it, the French internet. And that failed because hindsight obvious, well, of course, if you're not well connected to the rest of the world, or if you have gatekeepers in the way that you're connected, then an open permissionless system is going to beat you versus a closed permission system if all other characteristics are the same, right? And what decentralized finance allows is the same thing the internet did, which is a global first approach. I can build something and it can get to anyone in the world if they choose to connect to that network, and no one needs to give permission to that person to be able to connect to the network. They just need an internet connection and a private and a wallet, and suddenly they can interact with it. So there's still competing standards, right? Ethereum is a standard, Radix is a standard, Near is a standard, Avalanche is a standard, whatever. So that's still there. So there's still the permissionless battle. But what we're seeing at the moment, and like what I've seen with the European implementations, what's come out of China, are the governments going, oh, no, we want to control the network. And that's fine if they're inward looking. They're looking at their local economy and they're going, yeah, cool, we can build applications for this local economy. But as soon as they need to cooperate internationally across jurisdictions, suddenly you have competing standards where there is a geopolitical reason not to accept another person's standard. And again, I think that's going to get in the way of adoption. Eventually, CBDCs will be issued, my view is they will be issued on top of public permissionless ledgers, and we welcome any government that wants to come along and issue a CBDC on top of Radix. That's fine, that's all part of the rich tapestry of what is going to be built on top of these ledgers, some of which will be more along the lines of CBDCs, some of which will be very much in the permissionless space. We aren't in the business of questioning what people choose to build. We're just in the business of making sure that it's possible to build whatever it is that they want to imagine they will. But I think we're going to go through a period of competing geopolitical standards, and I think because governments are better funded and more competitive, that may last longer than what we saw in the enterprise blockchain space, which was relatively short-lived. That was the last question, because I really do need to let...
Guys, if anyone does have follow-up questions for peers, in our Telegram, you can tag your question with an AMA. Every 2 weeks, Dan, the founder of Radix and Piers, will answer a lot of technical questions, and Piers will pick up a lot more of these sort of strategic questions. And Matthew as well and the rest of the leadership team do a monthly call where they answer a lot of the pressing questions as well. So if you do leave, you do have a question, you can't answer it, hop in the Telegram, ask it there. Either one of the community moderators, the team, or the guys on the call will be able to answer for you at some point in the month.
Thank you so much, guys.
So welcome back to the Scripto tutorial. And now we are going to be starting building more interesting stuff. We are going to learn how to create non-fungible resources using Scripto by building a image collection of NFTs that will represent gumballs with different attributes. So you will learn how to provide flags and authority on resources to be able to specify that a resource is mintable and who is able to mint that resource. So we will implement multiple features. First, the admin of the component will be able to call a method on it to mint NFTs with different attributes. And then users will be able to buy specific or random gumball NFTs. So just before we get started, as a reminder, the resource builder, with the previous examples, we used it for simple resources. Right now, we are going to add some flags and add some authorities on them. So the flags that you can provide on the resource is, for example, you can specify that the resource is mintable, burnable, or that the shared metadata is mutable. That means that you can change the metadata of the tokens, like the name or the symbol, or any custom metadata. Or you can also provide flags like individual metadata mutable, which means that this is used for NFTs if you want to be able to update the individual metadata of a particular NFTs in the future. And you can see at the bottom right of the screen an example of a more complex resource definition. In this case, it's a fungible resource because we are calling the new fungible method. And we provide some metadata. And notice that this metadata may change in the future because in the flags section, we specify that it's shared metadata mutable. And you can also provide multiple authority. For example, you can say that a certain badge is able to only change the shared metadata, and a different badge would only be able to mint and burn the tokens. So let's get into the code for the fourth example. So open up the fourth directory, go into the src folder, and open up the lib.rs file. So now you can already see something different inside this blueprint definition. So we are importing another file here because we are defining the attributes of the NFTs in a different file just so the code is more readable. So if you go into the attributes.rs file, you can see that we define some enums for the attributes that the gumballs will have. So it will have a color, it will have a hat, and it will have highs. And then, after importing those attributes, we can define the structure that the NFT data will, the kind of NFT data the NFT will hold. So we define a structure gumball NFT data, and we define the three attributes, and each of their types is the attributes that the enums that we imported here. And so we will use this structure later when we are going to mint NFTs, because we will have to provide each of the attributes. And to be considered a data to be used for non-fungible tokens, you have to add this line here at the top of this structure. So now you can already see that it's getting more, the examples are getting more complex as the number of variables in the states is increasing a lot. So we will have a vault containing all the minted NFTs. We will keep a reference to the resource definition of the gumball NFT. And we keep this reference to be able to, because we will use a method on this resource definition to be able to mint new resources of this kind. Then, just like the gumball machine, we need a vault to collect the XRD. And then we will keep a reference for the prices of the NFTs. So in this case, we will have two prices. One, if you want, the price will be different if you want to buy a random NFT or if you want to buy a specific one. And those prices will be set when instantiating the component by providing parameters to the instantiator function, just like we saw in the previous examples. Next, we need a reference to the admin badge token so that we can protect some methods. In our case, we will be protecting the method to mint NFTs so that only the admin will be able to call that method. Next, there's a vault that will hold a minting authority badge. This will be, I will explain more about this later. And we keep track of the number of NFTs that we have minted just to be able to have an increasing number for the IDs of each NFTs. So because the code is getting more complex, let's get an overview of the methods and functions that we will implement. So first, we will have a function to instantiate a Gumball Club component. And as you can see, the function caller has to provide prices. And we are returning the component and a badge for, we are returning also the admin badge. Next, we will have a method called mint NFTs, and notice that it is protected so that only someone presenting the admin badge can enter this method. And when calling this method, the admin will provide the caller, it's a number, so it will be the ID representing the caller, an ID representing the and one representing the highs. And then, finally, we have two methods, one to buy a random NFT and one to buy a specific one. And notice that to buy a specific one, the user has to provide an ID to be able to choose which one they will get. So let's get into the explaining the implementation. So, first thing we do, inside this instantiator function, we are defining an admin badge. And this is the badge that we will return to the caller or to the transaction layer, which will later be inserted into the account calling this function. And next, we are defining a minting authority. And this has something to do with, remember how I said that you can, when you are creating a resource, you can pass some badges that are allowed to, that when you present them, you are allowed to mint the token. So this is why we need a minting authority. So this is just a badge, but this badge will be old inside the component instead of inside the account, because it's going to actually be the component that is minting the new NFTs and not the account directly. So we create a new badge, which is a fungible resource, and it's we only want one minting authority, so we create a supply of one. Next, we define the Gumball NFT definition. And now it's the first time that you see that we are actually creating a non-fungible resources. So this is the same, you create non-fungible resources the same way as you create fungible ones. You can provide some metadata. You can provide some flags. In our case, it will be mintable. We provide a badge that may mint. In our case, it's the minting authority that we just created previously here. And we decide to create no initial supply. So this is, instead of creating an initial supply for the NFTs, we will let the admin mint new NFTs. So the supply starts with 0. So that's why we are calling no initial supply. And when you're calling no initial supply, instead of returning a bucket, like initial supply fungible, it's returning only the resource definition. So that's what we are going to be storing inside the component. So this is what we are doing after to instantiate the component. We are providing all the variables to define the state. So the Gumball NFTs will be a new vault that will contain the Gumball definition address. So this will create an empty vault that will only be allowed to contain Gumball NFTs. Next, we store the Gumball NFT resource definition. We create a new vault to hold the collected XRD. Then we specify the prices, and it's equal to the prices that was provided through the parameter of this function call. We store the admin badge resource definition, and then we are storing the minting authority inside a vault. So we do vault with bucket, and we insert the minting authority bucket. And we initialize the number of NFT minted to 0. So after defining the state, we are calling the instantiate, and this returns us a component that we are then returning back to the caller along with its admin badge. So now for the mint NFT method that only the admin can call because of this macro at the top. what we are doing is first we are finding the NFT ID that this new NFT will have. So we are creating a non-fungible key, and we are creating it from the number of NFTs that is minted at the moment. At the beginning, it will be 0, and then we had 1. So each NFT will have an increasing number for its ID. Then we are initializing the Gumball NFT data structure. This is the structure that we defined here at the top. So we are initializing this structure, and we are assigning it to the NFT data. The NFT data variable here. And now for minting the NFT, we do this by first, how you will this is like a shortcut, but how you will normally do it is you first need to get the minting authority out of the vault, that is the vault containing this badge. So you would take a single resource from this vault, and then you will present it to the mint non-fungible method on the Gumball NFT. And then you will finally insert this badge back into the minting authority vault so that you can reuse it again in a future call. But this can be quite long to write. So we have added the authorize method on vaults. And this is doing exactly what I just described. So it is taking a resource from the vault, presenting it to mint, and then putting it back inside the vault. So when we are doing authorize, we have a reference to a badge that we can use when minting the non-fungible. So when we are calling the mint non-fungible on the resource definition, we have to provide the NFT ID, like this. This is the NFT ID that we just created here. And then second parameter is to provide the NFT data. And finally, the badge that we are presenting that has the authority to mint this resource. So this is then returned and stored inside this new NFT variable. And we simply have to insert it inside the Gumball's NFTs vault on our component state by doing a simple call to put on the Gumball NFTs vault. And then we are finally increasing the number of NFT minted so that the next call to this method will create an NFT with another number for its ID. Now, when you are to buy the NFTs, let's start with the buy random method. So it requires a reference to self because it's a method, and it has access to the state. And it also accepts a payment bucket, just like the other examples that we saw. And it's returning the NFT inside a bucket and another bucket that contains the change, just in case the user sent more than the required amount. So we take a portion from the payment bucket with payment.take, and we take self.price random, which is the price for buying a random NFT. So this is returning a bucket, and we are putting it inside the collected XRD vault. Then we are taking a NFT from the Gumball NFTs vault, and we say that we want to take one. And notice that we don't provide an ID for which NFT to take, so that's why we call it to by random. Next, we return the NFT along with the change back to the user. And now for the buy specific NFT, it's a little bit the same, except that it accepts an ID as the argument. And then instead of only taking one, we are doing take non-fungible, and this requires an ID, and this is the ID that we want to take from this vault. So we need to provide a non-fungible key, so we do non-fungible key from, and we provide the ID that was passed through the parameters. And finally, just like the other method, we are returning the NFT along with the change. So this is so this is the code for this example. Now we are going to run it. So open up the README file, and inside it you will find all the instructions to follow along. Again, because we are going to be creating a lot of addresses and we don't want to copy them around, we are going to be generating environment variables to represent those addresses. So to have access to those variables, on Linux and Mac, you can do source var.sh. And if you are on Windows, using the command prompt, you can run the there's again an error here, so you run var.bat. And next, we have the instructions on how to run it on Linux and Mac, and how to run it on Windows. So in my case, I will be running it on Mac, but if you want to follow along on Windows, just go down the README and copy the code, the comments that you see here. So go into the terminal at the bottom of the screen, and don't forget to run those commands here to have access to the environment variables. And we are going to be resetting our environment to start from scratch with resim reset. And next, we are going to create a default account that we will act as with resim new account. And the next step is to build and publish the blueprint on the local simulator with resim publish dot. So now this is building. So we are going to be calling the instantiator function called instantiate club. And we do this by running resim call function. We need the address of the package that we just instantiated here. And you can use the package variable. Now, if you're on Windows, it would be a little bit different. It will be to get access to the variables here, just as a reminder. Next, you need to provide the name of the blueprint. Now, it's a board gumball club, which is, again, the name that we provided here for the struct and for the implementation here. And we need to provide the parameters. So the first one is the price for a random NFT, and the second one is the price for a specific one. In our case, we want the specific one to cost a little bit more because the user will have a choice to choose from. So for a random one, it will be 15 XRD, and for a specific one, 30. Yeah, I forgot. After the blueprint name, you have to provide the name of the function, so instantiate club. So resim call function, the address of the package, the name of the blueprint, name of the function, and then the two parameters. Next, you can see, after running this, you can see that it has succeeded, and it created 4 new entities. This is for the badges that are created, the NFT resource definition, and also for the component that was instantiated. With the component address that we have here, we are now going to mint some NFTs as the admin. So we will call this mint NFT method by providing the admin badge. We can do this with resim call method. We provide the address of the component, which is stored inside this component variable. The name of the method that we want to call is mint NFT. And now, remember how the order of the arguments. So we have to provide a color, a hat, and a different highs, which will be, because each attributes contain three, each category contains three attributes. We will have to input a number between 1 and 3, or 1 and 3. So let's create one with a color 1, a hat 1, and a eyes 1. And now we need to provide the admin badge, and we want to present one badge, comma, the address of the badge, which is stored inside the admin badge variable, like this. So, so we can see that this succeeded. So now the component has a NFT on its inside their vault. So let's create two other ones, but with different attributes. So let's put different numbers for the first three arguments here. I will do one with 1, 2, 3, and another one with 3, 2, 3, like this. So now we can verify the NFTs that were created are stored on the component by doing resim show and the address of the component. So we can see that it has a 3 resource of the Board Gumball Club NFT. And you can see the data that it contains here. So this will represent all the 3 attributes. And you can see the ID of each NFT. So the first one that we minted was 1, second one 2, and just like we defined on the minting method. So now we will try to buy one. We will buy a random one by calling the buy random method with resim call method, the address of the component, the name of the method, buy random, and then we need to provide a bucket containing 15 XRD. You write it as 15, comma, the address of the XRD resource, which is stored inside the XRD variable, like this. So let's do resim show and then the account address just to verify that we received it. So when we look into the account, we can see that indeed we have received the NFT, and the one we received was the one with ID 1. Now, what if we want to buy a specific one? Let's say the number 3. We can do this with resim call method. Again, the address of the component. But now we are going to call a different method, so buy specific. And now the price to buy one is not 50, it's 30. So we send 30 XRD. And the last parameter is the number, the ID representing the NFT that we want. In our case, we will buy the one numbered 3. So we can copy this this long number here, like this. And when we call it, we don't get any debug because we didn't write any inside the method. But we can again do resim show account just to verify that we received the right NFT. And indeed, we still have the first NFT, and we now have the third one. And if we do resim show with the component address, we can see that it only has the second NFT that was minted. So this is how you create non-fungible resources using Scripto, and how you provide badges and authority on the resources. Now, before we go into the questions, I'm going to do the final example, which will be a decentralized exchange, just like a little bit like Uniswap, if you know a little bit about it. So this will be a more concrete example, and you will learn how to use the transaction manifest, which is something that we are talking about since the beginning, but we haven't really showed you. So this will allow you to compose component calls to do really nice, to do more complex transactions. So for this blueprint, we will implement features such as the users will be able to provide liquidity and remove it. And also users will be able to swap tokens. You can see a diagram of how our blueprint will look like at the bottom left. So it will contain 2 vaults, one for a XRD vault. Well, it can be any token. So 1 vault for the token A and another vault for the token B. It will have a function, instantiate pool, and it will have 3 methods. One for adding liquidity, another one to remove it, and another one for swapping tokens. So quickly, just before we get into the example, what is an automated market maker, which is what we are going to be building. So instead of like centralized exchanges, they use something called an order book, and they are matching buy and sell orders together. This is not really really good on decentralized ledger. So we are going to be using another technique, which uses pools of token. Instead of trading against instead of matching orders directly together, you will match your order with a pool of tokens directly. So how do we get tokens inside the 2 pools? Well, users are able to provide liquidity in the pools, and in exchange, they are receiving a special token, which is, we will call it the liquidity provider token, which represents the amount, the percentage of share that they are owning inside the pools. And then others are able to swap tokens and pay a fee, and this fee is indirectly given back to the liquidity providers. You can see a diagram of how it will work. So you are withdrawing from your account, and then you will send the XRD that you are withdrawing to the swap method, and then the Radix swap component will do some calculation to know how much of the other tokens to send you back. Before we go into the transaction manifest, we will go into the code. So open up the last folder, the 5th one. And now the component that, well, we will call our blueprint Radix swap, and the components that are instantiated from it will contain different variables, like the LP resource definition, LP for liquidity provider, and again, we need to store this resource definition inside the state to be able to mint more of these resources. We will also have a vault to hold the badge authority that is able to mint LP token, just like we did in the previous example. And we have 2 pools, one for the A token and one for the B token, and they are represented as vaults because they will be storing the tokens. And finally, we are storing the fee that the user will have to pay whenever they want to do a swap. So now when you are calling the, before going into the implementation, we just do a quick overview. So we have the instantiate pool function that accepts so the user instantiating the pool is actually also providing liquidity, the first liquidity to it. So they have to provide A tokens and B tokens by sending buckets. And then we need to know how much of the initial LP tokens to create at the beginning. So how much LP tokens the instantiator will receive for having provided the initial liquidity. And then they are able to provide a fee. And next, we will have a add liquidity method that people are able to call with A tokens and B tokens to add liquidity to the two pools. And they are receiving back their reminder. I will explain what it is later. And also the bucket containing the LP tokens that we are going to be minting. Next, for the remove liquidity, how it works is the user will return back their LP token, and depending on how much they return, we will do some calculation to know how much of the share that of the pools they actually owned, so that we can take back those amounts from the pools. And finally, for the swap method, it will accept input token. Either it can be A tokens or B tokens, and depending on which one the user sends, they will get back the other ones inside this bucket that we are returning. So for the implementation, for instantiating the pool, the assert here is something new that I think I haven't showed yet. So this allows you to do some assertion and some checks inside your code, so that if it fails, well, the whole transaction will be cancelled and reverted. So we are first making sure that the instantiator is not sending empty buckets for the initial liquidity, and also that the fee is between 0 and 1. After that, we are creating the LP minting badge. This is a badge that will be used to be able to mint LP resource definition that we will create right after. And remember, this will be stored inside the component itself, so that the component is able to mint new resources. After that, we are defining the actual liquidity provider resource definition. We provide some metadata, such as a symbol, a name, and we can also provide URLs. You can write anything you want in metadata. You can put a description, you can put custom fields, anything. For the flags, we want this resource to be mintable and burnable. Burnable because when the user is returning them, when removing liquidity, we are going to be burning those liquidity provider token, so that the calculations are right in the future calls. And then we provide which badge has the authority to mint and burn, and it's the LP mint badge that we just created before. And the LP resource def, we are creating it with a no initial supply, just to show a different way of minting the resources. Another way would be like we did before, with initial supply fungible, and we provide the amount. But now, just to show a different way, we are doing the minting separately. So to mint, we take the resource definition and we call the mint method on it. We provide how much of this token that we want to mint, which is LP initial supply, which was provided with through the arguments of this function. And we present the LP mint badge, so the authority to mint. And this returns us a bucket containing the initial LP tokens. And this is something that we will be returning back to the transaction layer. And finally, we are instantiating the component variables, exactly like we did before. So let's go, before going into the add and remove liquidity, we can start with the swap function because it's more interesting. So the swap method requires an input token that the user is providing. And next, The first step of this method is to calculate the fee that the user will be having to pay. So we do this by multiplying the fee by the amount that the user is providing. We can call the amount method on buckets to get how much was sent. And we are also storing the input amount inside a different variable just for debugging after that. Next, we are looking into, we are checking if the user is sending A tokens, because if it's the case, we are going to send B tokens back. And then we are, after that, we will be checking if they are sending B tokens so that we can do the inverse. So, for example, if they send A tokens, so this branch here, we calculate the amount of B tokens that we have to send back using this formula here. And then we insert the input tokens that the user provided inside the A pool stored on the component by doing self.apool.put and the bucket that the user provided. And after that, we are simply doing simply debugging some information, and this will be useful for when we are doing the transaction manifest. And finally, so we are returning B token. So we take from the B pool the B amount that we calculated. So this is the first branch. The second branch is exactly the same, except that the two tokens are inverted. So I won't go over it since it's the same thing. Now for adding liquidity, we first need to find the ratio of the A tokens that the user is sending. The ratio of the A token that the user is sending with the amount that is actually in the A pool. And we are doing the same with the B ratio. And next, we are computing the actual ratio and the reminder, because we want the A tokens and the B tokens to have the same ratio when you are putting them inside the pools. So we are finding the smallest ratio. So if it's the A, we are going to be putting inside the A pool the full amount of the A tokens. And inside the B pool, we are going to be taking the A ratio, so that is the two tokens you are inserting have the same ratio. And finally, you are this is Rust syntax for returning the A ratio and the B tokens here to store them inside the variables here. So the actual ratio and the reminder will be equal to this and this specific branch. And again, we do the same thing for the inverse. So we will only invert the B with the A. So I won't go into the details of this. After that, we need to know how much LP tokens to mint. For that, we are getting the total supply of the LP resource def by calling the total supply method on the LP resource def variable stored on the state. And we do this times the actual ratio. The next step is to actually mint this supply by, just like we did in the previous example, we are using the authorize method on a vault that is containing the badge as a shortcut. And we are providing this, this is giving us the authority to mint, so we are providing it to the mint method on the LP resource definition. And finally, we are returning the LP tokens and the reminder, if there's any, to the user. For the remove liquidity, it's a little bit simpler. The user only sends the LP tokens, and then we do a assertion to make sure that they are actually sending us the LP tokens and not something else. After that, we are finding what is the share that this number of LP tokens represent by doing this division. We are dividing LP tokens amount, the amounts that is provided by the total supply. And then we are withdrawing this share from the A pool and the B pool. And finally, we are burning this LP token that was provided with the badge contained inside the vault, just like you are doing when you are minting. But now you are calling the burn with auth on the bucket that is provided by the user. And finally, you are returning the withdraw amount for the 8 tokens and the B tokens. So now we are going to be testing this example. We are first going to be testing it manually, and then we are going to be using the transaction manifest to do something a little bit more complex and composing calls to different to communicate with different components. So open the terminal at the bottom of the screen and go inside the 5th directory. And just like we did in the other examples, we are going to be generating environment variables by running those 2 commands, depending on if you are on Linux, Mac, or Windows. So I'm doing source var.sh. Now again we want to start from scratch, so we do resim reset. We create the default account with resim new account. And to be able to actually do trading between 2 tokens, we will create a new token. And this can be achieved by simply calling the new token fixed command with using resim. So we will create a Bitcoin token with resim new token fixed. The name, which will be Bitcoin. A symbol of BTC. And the amount that we want to create. So in this case, 21 million. And this is returning us the resource definition address of the token. And we will be using it later. For the next step, we are going to be publishing the package with resim publish dot. Again, now this is building the code, and then it's going to be making it available on the local simulator. So after it creates the package, we have access to the package address. We will use this to instantiate the component. So in our case, we will instantiate the component with the token will be a bucket of 100,000 XRD. The second parameter will be a bucket containing 1 million BTC. And for the third parameter, which is the initial supply of the LP token, we can put 100. And for the trading fee, we will put 1%. So we can achieve this with resim call function, then the address of the package, which was stored inside this package variable, and then the name of the blueprint, so RadiSwap, the name of the function that we want to call, so in our case it's instantiate pool, and now we are providing a 100,000 XRD, so we write 100,000, comma, then the address of the XRD token. The next parameter is the BTC that we will provide for the initial liquidity. So we are sending 1 million of BTC resource as a bucket. Next parameter, 100 for the LP initial supply, and the final parameter, 0.01 for a 1% trading fees. So now we can call the so now the component as liquidity for the two tokens. So we are able to do a swap. So let's try this. Let's try to swap 100 BTC for some XRD. By doing resim call method, the address of the component, the method name swap, and we want to send a bucket of 100 BTC. And now you can see that the debug tells us that we have received 9.899 XRD, and we can verify this using resim show account. Resim show, and then you write the address of the account, or you can use the variable that was created. So we can see that we have received some more XRD. So now we are going to try the transaction manifest to do something more complex. We want to first withdraw some XRD from the account. We will withdraw 25. And then with this 25 XRD, we are going to be buying a gumball by calling the gumball machine. And with this gumball, we are going to be swapping it on the Radix swap to get some BTC. And then we are going to be inserting this BTC inside the Alice account. So to try this, I've provided a script to automatically go inside the gumball machine directory and deploy it, and then go into this Radix swap directory and deploy it. Also, so you can run just like you did for the environment variables. You can do if you are on Mac or Linux, source, and then setup composability.sh. And if you are on Windows, this will be a little bit different. So you are running the setup composability.bat. If we go into the script, we can see that it's resetting the environment, creating new account like we did before. But then it's going back into the gumball machine, publishing it. It's getting 3 gumballs so that we can provide it as liquidity when instantiating the Radix swap component. So now the environment is set up to be able to run a transaction manifest doing the steps that I explained. Let's see how the transaction manifest actually looks. So you can open the composability example.rtm file. And so this is how a transaction manifest looks like. If you want colors, because I think you might not have it at the beginning, you can install the RTM color extension provided in this the same repository by right-clicking the RTM color.vsix and doing install extension here. This will provide you a color in this in the transaction manifest. So like I said, the first step will be to take 25 XRD from the account. And since the account is a component, we are calling a method on the account address component. The method that we are calling is the withdraw method. We want to withdraw 25 of the XRD resource. And this is this is reference to a badge that is allowing your account to actually withdraw from this account component, so that you cannot withdraw from any component. The next step, it will be to buy a gumball from the gumball machine component. So after calling the withdraw method, it's returning us a bucket, and this bucket goes into something that we call the worktop which is the concept for the transaction manifest. And so after it's on the worktop, we have to take it back and put it inside a bucket that we will give a name to. So we do take from worktop. We want to take 25. And again, this is the address of the XRD resource. And we are going to name this bucket XRD payment. And to buy a gumball with this bucket, we are calling the method buy gumball on the, this is the address of the gumball component. And we are providing as parameter the bucket named XRD payment. After that, we are doing essentially the same thing. We are, but for calling the Radix sub component. So we are again taking from the worktop. Now we are taking one, and what we are taking is the gumball resource. So we specify the address of the gumball resource, and we store it inside the bucket name gumball. And then we send that bucket to the swap method. And an extra step that we can do that is really nice with the transaction manifest is to actually do some assertion directly inside the manifest file. So on other smart contract platforms, what if you want to do complex transactions like this, you actually have to deploy a smart contract that is implementing this logic. And then if you are, after deploying the smart contract, if you want to actually change the assertion or changing something else, you have to redeploy another smart contract, essentially. So, so now what we are doing is asserting that the worktop contains at least 10 BTC. If, for some reason, the number of BTC is less than 10, it will fail and revert everything that was done in the previous previous calls. And finally, we are inserting all the resources back into the account by calling the deposit batch method on the account with the a call method with all resources. So this take all the resources on the worktop, put them inside an array of buckets, and send this array of bucket inside the account component. So now that this is explained, let's try to run it with resim run. And the name of the transaction manifest file, which is composability example.rtm. So when running this, now the result will be a little bit more complex because we are calling more components. But you can see that we are getting the debug from the gumball component when we are buying the gumball, and then we are getting the debug from the Radix swap component to say how much we are actually getting of BTC. And now if we call it again, so this will exchange another gumball for BTC, but we see that the price of BTC just decreased. That's because that's how automated market makers work. And whenever you buy a token, it's decreasing the price of the other one so that there's a constant product between the two quantity inside the pools. So let's try to call it another time. And now you can see that it fails because now the amount of BTC that we will get from this running this transaction manifest is less than 10. So we are safely not losing any XRD when buying gumball because everything gets reverted. So this is essentially how you build a simple AMM using Scripto. So we will now answer questions.
Anyway, that one works now. So for later.
It works now?
Now it works, yeah. But for later, just so you know.
Mike. Hi. Hello. Hi. Hi. Thanks for the presentation. I had a question, but probably not so Scripto related. It was probably related with peers better, but I'll give it a shot anyways. Before the release of Babylon, are there any plans to make any one-click solution to buy Radix? Or I know the when Binance question comes up quite frequent, but my question is how can we make it more user-friendly until the Babylon release? Any on-ramp suggestions or any kind of solution for now?
Yeah. Hello. Can you hear me? Am I on? Yeah, there I go. I just went all that trouble to tell you I can't really provide an answer to that question, but you know, it's definitely something we would like to do. I mean, we're always looking at you know, more easier ways for people getting access to the Radix token. Don't have anything to announce right now, to be honest with you. It's definitely something that we're working on, and there are a number of different ways that we need to measure sort of what's going to be the best way of going about it. But I wish I had something concrete to tell you, but there's stuff in the works, but I can't talk about it right now.
So remember, if you want to ask some questions, just scan this QR code and you can ask your questions on this platform. And you can also vote for the best question that you prefer, so that to make sure that they are answered. So someone is asking, is there something like bucket.takeAll, like vaults have, or should we use bucket.take and providing bucket.amount? We actually have a shortcut for this. So if you want to put a bucket, someone sends you a bucket and you want to send the entirety of it inside a vault, what you are actually going to do, if I'm opening this. So let's say that you have a vault. And you want to insert, let's say, this LP token bucket that we received. Instead of doing like what was suggested, which is vault.put LP token.take and the amounts, so LP tokens.amount, there's actually a shortcut. So we can simply do vault.put and you write the bucket. So vault.put and LP tokens. This is actually a question that we get a lot in the community, but the solution is really simple. You just put the complete bucket without specifying the amount. What is the resource definition address used for when instantiating the component? I'm not sure which component this person is talking about, because we didn't have functions that accept resource definition. So if you want to give more information in other question, it would be great.
Is the person who asked that question in the room, or is that a remote one? Okay.
For mint NFT method, why not use the enums defined in the attributes? Why unsigned int? So the person is referring to the NFT example here. So here, why do we have to provide the number instead of saying the instead of accepting directly the enum? And this is a limitation right now with Scripto. You cannot, I believe, you cannot accept enum's value directly from your method parameters. So that's something that we have to do at the moment. But if we see that this is something that the community is asking a lot, this is maybe something that we can implement. In Scripto, what happens if a method panics? So just like when there's an assertion that fails or something that's not happening correctly inside the code, everything will be rolled back, and no state will be saved on the ledger.
Yeah, the basic rule is in the transaction, everybody has to be happy. If the assertions that are in the transaction manifest, all the components involved, everything has to complete execution and be able to do all the things it tries to do. If there's any problem anywhere in there, the entire thing back to the beginning of the transaction, it doesn't even roll back. It never actually happened. Everything is sort of a potential change of state up until that point. And this is really important to ensure that you don't have sort of unexpected combined results where part of it went through, but then the rest of it didn't. You really want to make every transaction be an atomic all or nothing thing.
How do you provide provably verifiable random numbers for Scripto application? I don't really have an example right now to show you, but this is something that we will have to provide if.
Yeah, I mean, this is a really tricky one. This one also gets asked a lot because people think of applications. They go, oh, it'd be cool to have like a randomized result that comes out of the thing. Unfortunately, this is actually a really hard problem. I mean, this isn't like a Scripto thing. It's just the idea of random numbers on a public ledger is a really complex thing because the rule is that any transaction, anything that happens, this is Ethereum, Radix, anything like that, you need to be able to prove that the result was correct based on the inputs of the transaction and the state of the network or the state of the ledger at that period of time. Everyone in the network needs to agree, yes, that was the correct result of that thing. All the nodes need to agree. This is like the nature of consensus, is that you have to have a deterministic result of a given transaction. Well, the problem with that is that you can't have, what this means is that if you're going to have a random number, this means that anybody running that transaction at that time needs to come to the same random number as everybody else does, or else you're going to get a different result and things get really weird. So there's a conflict there. There definitely are techniques you can use to produce pseudo-random numbers to do things like this. But it's a really, the problem is probably like the number of use cases you'd actually want to use that for is fairly narrow because all of those things, because it has to be a deterministic result, it means that anyone observing the network at that time would be able to say, I know what that random number result is going to be, and they might be able to front run you and get some result that you didn't want. It's, I would say that truly random results on a public ledger may be an unsolved problem. Things really need to be predictable.
What's the big difference between badge, auth, and Solidity ownable? I don't know what are ownable and Solidity.
Yeah, I'm trying to remember what the ownable thing is. I don't know offhand, I'm afraid. This would be a good one to ask to like the, tag hashtag AMA on the Telegram channel, and we can get back to you on that.
And again, for this one, I'm not sure what is payable and so is this for? I think it's view methods is for methods that are not updating the state.
Yeah, if that's what you're referring to, like a read-only method, I mean, yeah, you could do things like that, but I'm not sure if that's what's being asked. Again, I think this is another one that we should probably follow up on. Yeah, I'm trying to remember specifically what those are in Solidity. Sorry.
So is the assert in Scripto similar to the assert in Solidity? or is it closer to require? Again, I'm not sure.
Yeah, I'm not sure. I mean, it kind of follows the Rust pattern, I guess. You basically assert you're specifying a statement, and if the result is true, you pass. If not, you panic. Is basically the model. I'm not sure exactly the differentiation on Solidity, but.
Next question. How would one implement a central limit order book in Scripto? Well, actually, there are multiple examples of doing this in Scripto that the community has made. So at the end of the presentation, I'm linking to the community example repository. You can go on there and find a limit order book, example using Scripto. What would be the best marketplace to trade NFT based on Radix? At the moment, NFTs are not part of the platform. They will be when Babylon launches. So at the moment, you cannot trade NFTs.
Yeah, one thing I'll say: if people are following Radix, you might see people that are doing NFTs today. It's kind of it's cheating a little bit. We can issue tokens on the Radix network today, and so we do have some people in the community that are creating kind of pseudo NFTs on the current Radix network by essentially doing either supply one tokens that can represent kind of something like an NFT, or they're issuing like vouchers that can be redeemed for NFTs once we get to Babylon. So there's some of that stuff going on. I'm not going to make recommendations about marketplaces and that kind of stuff. That's up to you. But yeah, as Clement was saying, the NFTs that we're talking about today that are truly unique NFTs that have attributes and all these sorts of things, this is all right now part of the simulator environment. All that capability is going to be available on the public network, which would mean they're available on marketplaces and that kind of stuff at Babylon launch in Q1 of next year.
Do we have a planned similar workshop in France? And maybe more general question, do we have more workshops similar to this planned?
We have workshops. I can't announce them right now. I'd say that this actually, I'll use this as a segue actually. If you're excited as in general, we definitely want everyone getting and joining our community, getting involved in the community. It's a really welcoming community. If you go to the hub for information about Scripto developers is developers.radixdlt.com. Developers plural. If you go there, there's information about our community channels. You can sign up for our developers mailing list, which I definitely encourage you to do. We actually have a problem with our list software right now, so you have to get on the waiting list, but we'll get you signed up once we get that working again. But that'll get you kind of on the list. You'll provide your GitHub ID, and this allows you to participate in a lot of kind of cool programs we have, competitions we're doing, and we also have linked there to an events section, so you can follow along on as we announce new events like this in different places. We're going to do in-person events, we're going to do virtual events. There is a lot of stuff coming this year. In terms of French speaking, we have a French speaker, so we should do something like that. Nothing planned right now, but yeah, I guess French speakers have an advantage that we already have to have the expert in the right language, so we probably should do something like that. I guess at this point, I'll leave that question for now. I'm going to call Christoph up to the stage. He's going to give you an idea of the agenda for the rest of the evening. I think we're going to take a short break, and then we're going to do a little more Q&A for people that want to just ask general questions. There's going to be some stuff going in the evening that Christoph can talk about. But yeah, once again, if you need to depart at this point, and you want to have your evening, that's fine. Again, really encourage everybody to get involved in the community. Get on the Telegram channel. Get on our Discord channel is great. The Discord channel has channels for both Scripto developers. We've also got like a Rust beginners channel. If you just want to ask general questions about understanding how Rust syntax works, it's all very welcoming. We've got a great community of people there, and we'd love to see you there. So, thanks.
Okay, I would like to call Ricardo on stage, our head of community in Portugal. Okay, in a few seconds. In the meanwhile, make sure that you're getting ready for open bar, as already mentioned. Goodbye.